Nkrumah University of Science and Technology from Ghana, British Food Journals into this conference. On behalf of the Universitas Brawijaya, I would like to express my sincere gratitude to all of stakeholders, especially for organization committee from Department of Agriculture, Socio-Economics, Faculty of Agriculture, and university partners, guest editors, keynote speakers, chairs, discussions, and presenters in this conference. We hope that the conference will be successful and enjoyable to all participants. In anticipation of fruitful and production of this discussion and this conference, officially I open this conference. Thank you very much for your kind of attentions. Enjoy your conference. Thank you.
Thank you very much, Prof. Widodo, for the speech. And before we run into the next agenda, I would like to remind to all of the participants to keep your microphone in mute mode so that it will not disturb the sessions. Okay, continuing the next agenda, I would like to invite Associate Professor Zawali as the chair for the first sessions. She is an associate professor in finance at the Faculty of Agribusiness and Commerce, Lincoln University, New Zealand. To Dr. Lee, time and screens are yours.
Okay, thank you. So welcome everyone. Welcome to the first session of today's online conference. So it's my great honor first to introduce our keynote speaker, Professor Fu Jingyi, who is from Nanjing Agricultural University, China. He is now the chair of AAEA's China section, and Dr. Yi is mainly engaged in agricultural policy analysis, agricultural risk management issues related to ecological environment and climate change. Professor Yi is awarded Leading Talents of the National 10,000 Talents Program in 2021, and he has published more than 50 articles in top journals in the related fields, including American Journal of Agricultural Economics. I know it's very hard to publish there. Food Policy, Energy Economics, also very top journal in the energy field. So I look forward to Professor Yi's keynote speech. Yours now.
Thank you, Professor Lee. Okay, let's share my slides. Okay. I assume you all can see that, right? Okay. A second. Okay. Yeah, thank you so much for having me here, and also it's my great honor to present my recent studies. Well, actually, I combined a couple researchers together, so I give a very comprehensive topic title for this presentation named "Investigate the Potential of Traditional Technology for Sustainable Food Production," which is not quite well, it's not quite common for us to know that traditional technology also has the side effect or the overspill effect for sustainable agricultural production. So here's the issue we try to focus on. The first, we know that grain supply is critical to food security, right? But also we all know that to provide a stable grain supply, we also have have a couple challenges, including like land and water scarcities, and also climate change, and also public health emergencies and conflicts. That's like kind of what we happen, right? Happening in the world, as a world. And also we have the population increase and the dietary demands change with the developing economic development. So what we gonna do to deal with those challenges? Normally we have two ways. First, we try to reduce the crop failure risk, and also we try to increase the core crop yield potential. Right, that's what we succeeded in the last 50 years. Okay, let's see how we're gonna increase crop yield. We adjust our inputs, for example, like fertilizers and pesticides and irrigations, and also we try to use more new breeding technologies, and also we try to subsidize the farmers, try to stimulate those farmers to produce hard, and also they have more output. So that's what we have down in the last century. And another way, we try to reduce crop failure risk, including like reseeding after flood, and also we try to use the drought resilient varieties. Okay, so but what I said, that's very common, or that's like common knowledge for our economists. So we try to ask whether, like for example, those traditional technologies has other effects on both increase crop yield or could reduce crop failure risk. Like what? Like mechanization. We use machinery harvest. We use machinery to plant. Whether they could reduce risk or increase yield. So before we investigate more, let's give you guys a little bit background about what happened in the last 3 decades in China. So we experienced rapid increase of agricultural machinery uses in China from 1990 to 2020. Okay, basically the total power of agricultural machinery, like panel A, what do you see? It has a rapid increase, right? Typically after 2004, because the subsidies, and also the comprehensive agricultural machinery rate actually increased from 22% in 1990 to 71% in 2020. So annual increase rate is about 4%. Almost of them are driven by the heavy subsidies. That's the background. So let's go back to the mechanization. So we all know that mechanization could be a very good factor to substitute labor because of the wage increase. Okay, and also it could increase the production scale, also increase agricultural productivity. That's what the traditional economic theory tell us. But if we go into the observe the real production practices, we could easily find that if we try to use more machine to harvest, that could relax the timing constraint of farming through 2 channels. First, typically for the like intra-annual rotation pattern, it could first guarantee the prompt harvest of the first crop, and also we could release the land timely for the next crop ploughing and sowing. So that's very important for the intra-annual cropping pattern areas, like most of areas in China. So let's try to see more details about the first channel, risk reduction. So for example, from this table, you see that the harvest season for winter wheat, okay, this today I'm going to talk about the winter wheat production. Okay, so for the winter wheat harvest season in China, normally starts from early May to early to middle of June. So it's about like 40 to 50 days. And but the rainy season in North China starts from June to September, and also rainy season starts from April to September in South China. So we see that from this table, we see that there are 1 or 2 months overlaps for the rainy season with the harvest season. So the continuous precipitation could have a low temperature, less lighting, water logging. All of them will drive crop failure. That's a risk. And if we go to investigate more about what really happened in the weather. So this graph tries to show you that no matter is the total amount of continuous precipitation, the top panel, right, the blue curve, and nor the frequency of the continuous precipitation, the times of continuous precipitation in the last almost 30 years. Both of them increase. So that means the crop failure increase, the crop failure risk increased in the last 3 decades. So if we consider right now, because most of harvest stage, farmers try to use more machine to harvest. So basically, from the literature or from the agronomists, they tell us that if we use a mechanized operation, it normally takes about 63 hours per hectare. If we use traditional manual operation, that takes almost like over 300 hours per hectare. So basically, mechanization could save almost 300 hours per hectare. If we focus on the harvest stage, if mechanized harvest could save more than 4 days. So that's very important in the harvest stage. That means if we shorten the harvest days, you will quite avoid more risk of the continuous precipitation. That's quite important. So that could reduce the weather-related yield loss for winter wheat. Okay, that's the channel 1. For channel 2, the yield increase. Here we're still talking about the winter wheat production, but it's in the intra-annual rotation pattern. Normally, we have 2 typical rotation pattern. Winter wheat. After that, it's the summer corn, or winter wheat and rice. That's very commonly used in most of China. So we see, well, it's quite completed, but normally we just focus on the red curve. You could see that the interval between winter wheat maturity dates and the summer corn planting dates actually decreased from almost 8 days to 5 days. Okay, it has increased by 3 or 4 days in the last 3 decades. But if we look at the winter wheat and rice rotation pattern, it almost decreased similar days. Okay, that's very, very straightforward to imagine that could increase the let's see this graph, that could increase the growth season for summer corn. Okay, so for panel A, suppose the manual, if traditional farmers use the manual operation, the growth period for summer corn is actually shorter than the farmers use mechanized harvest, because the interval between harvest of wheat and planting corn is actually decreased. Okay, if this is based on the assumption that farmers use the traditional corn variety. Okay, but since there is a larger planting window for the summer corn, actually farmers could choose better corn varieties. Actually needs more growth stage. So they could, the second graph or a second panel just to show you that the farmers could change their corn varieties. No, not only for simply extend their corn growth season, they just change their corn variety with better yield. Okay, here's what we observed in the history. Okay, for the well, this kind of interesting one. For the y-axis, it shows the date from January 1 to January 1 as day 1, and also we called the December 31st is 365. So basically, we see that the date from January 1. Okay, we have a sample from 1992 to 2013. Okay, if we drop the middle one third of the sample, and then we split the sample to the starting part and the end part. So we see that from 1992 to 1998, the planting date for summer corn is almost like a 167. Okay, but if we look at the planting date in the period of 2003 to 2013, actually the planting date has decreased to 162 or 3. So it's decreased by 2 or 3 days. And also, we observed that the length of corn growing season actually increased. For the right panel, you see that the first of our observation period, the growth period of length of growing season for corn is almost 100 days. Okay, from planting to.
It seems we have no voice now.
Yes, I can't hear the voice either. Maybe we wait for Professor E a few minutes to come back. So we'll wait for Professor E. It seems.
Well, sorry.
Oh, okay. You come back.
Yeah. So well. Did I talk about this one?
Yeah, I think the last slides you talk about is here.
Okay, great. So we try to provide some evidence to show that our hypothesis could be acceptable. So we choose the study area in winter wheat and summer corn cropping areas, and also that takes about like 60% of the arable dry land, and also we try to prevent some empirical evidence to show that the mechanized winter wheat harvest could reduce the risk and also increase the yield of corn. Well, for the risk reduction effect, we use the skewness of a winter wheat yield. That's actually the traditional. Well, it's, I could say that's the residue power over 3. This kind of cubic power. That just show you that skewness of the yield, to prevent to represent the downside risk. And also we use the mechanization level to capture the mitigation effect to the continuous precipitation. I don't want to talk about too much about the techniques. For the second hypothesis, we just use the mechanization usage for winter wheat. The dependent variable is the corn yield. Okay. Well, the data is from the Chinese Academy of Agricultural Sciences, and also that's a county level data. And also we have the weather data from China meteorological data sharing system. Okay. And also the study area is kind of traditional winter wheat production area is around here. Okay, the result here from this curve, it shows that winter wheat has the left skewness. That means it has downside risk. And if we look at the regression results, so the blue texts to show that the continuous precipitation, or no matter what model we choose, it has significant result to show that the continuous precipitation has adverse impacts on the skewness of yield. That means continuous precipitation actually increase the the yield losses. Okay, but if we look at the interactor term about the continuous precipitation and machinery, all the terms are significantly positive. That means machinery harvest actually decrease the yield reduction risk. Okay, it's kind of very, very strong evidence to show our first hypothesis. Also, we do a simulation to see that to check which area has plenty of machinery. So basically, let's just move to the right panel. We show that there was a critical level of mechanized harvest level. It's about 2.4 kilowatt per hectare. That's a critical level. On the right-hand side, more harvest machinery usage. That we expect that in this area, those mechanized harvest could completely mitigate the precipitation adverse impact. On the left-hand side, we still have the potential to increase mechanized harvest. So different areas, they have different potentials. Okay, this is just a simulation result. So that means even in China, our mechanization rate is has been over 70%. We still have potential to increase mechanization. Okay, this graph just to try to show that the heterogeneity analysis. Well, it's quite common for China. We transport the harvest machinery from one region to another one through highway. So we expect that in the areas with highway density, that mitigation effect of mechanized harvest to continuous precipitation would be larger. So that's consistent with our expectation. And also for plain area, it's more easy for extending mechanization, right? So the mitigation effect is larger, but we don't find significant differences between North and China, South China. It does not really matter for that. And also for the channel 2, we try to first we want to see that whether the mechanized harvest of winter wheat could increase the corn yield. Well, we find very, very strong evidence too, right? That all of them are positive. And for the mechanisms, we try to investigate. For example, the corn growing season length. We see that wheat harvest machinery has increased the growing season length for summer corn. Okay, and also for the time interval between winter wheat and summer corn, it has significantly negative effect for the winter harvest machinery. And also for the planting days, it has a negative sign too, right? And also we see that it's possible the total planting dates, dates, it has also increased. So that provide evidence, or we could expect that farmers could advantage of this kind of length increase to adopt more advanced varieties of summer corn. So conclusions. So it's kind of straightforward to conclude that actually mechanized harvest of winter wheat has mitigated the downside risk of wheat, okay, from the adverse effect of continuous precipitation. And also mechanized wheat harvest has a significantly positive on the corn yield through planting dates or from the possible cultivar shift of corn. Okay, so I think that's all. Thank you.
Thank you, Professor. So I think now we have Q&A time. You can either type your question or you can ask Professor using your voice, Either way is fine. Any questions? I look forward to some questions.
I think somebody raised hand.
Oh,
You see that?
I haven't seen that, but please just to talk.
Riska.
No, I haven't seen that.
Yeah, thank you. Okay, thank you very much for this presentation. It's excellent presentation. I would like to ask about what is kind of harvest mechanization on wheat yield. I don't see about the you mentioned before. Thank you, Mr. Fuji.
I'm sorry, could you repeat that again? I can't hear that clearly. You didn't see what?
Yeah. What is kind of harvest mechanization of wheat yield that you mentioned about that?
Okay. Well, I'm not quite for sure whether I got your question, but I think because we actually use the total agricultural machinery use, but typically we just estimate, or I could actually precisely we should say that we estimate the harvest machinery from the county level data, and also from our observation, we only have 30 years. Oh no, sorry, it's not for 30 years. Yeah, 30 years data. We don't really have the most recent data I'm not quite for sure. Am I answering your question?
I think she's happy because she doesn't have follow-up question. Okay. So I will move to, I see Wanima raise your hand. So what's your question?
Okay, thank you, Professor Yi, for your very interesting presentation. I have a question related to the risk measurement of the yield. So normally when we analyze the risk of the yield, we also consider the yield variance, because yield variance is a way to measure the yield variability. So in this study, you considered the yield skewness. And the yield skewness is usually used to measure the exposure to downside risk. So my question is, whether you have considered to use yield variance as a dependent variable to reflect the production risk or yield risk.
Okay, I got it. Thank you. That's a really good question and a tough question. Actually, we used to use variance, but when we submit to the journal, the editor said, you have to use the skewness, because I think that's reasonable, because variance measures the variation of the yield. But really, that's if farmers face the yield increase, so they are happy. And also we have no question about that, because we have more food, right? So we really care about the downside risk. So so we finally try to use the skewness of the yield. But in our empirical research, we actually include both variance and skewness. Well, I should say that the conclusions are very consistent. So no matter the mechanized harvest, no matter what, it has increased, reduced the yield variance and the skewness. So, but here I just present our the key results to the reduction of skewness through using mechanized harvest. Okay, thank you.
Okay, thank you.
Yeah.
Okay, so I see Puneet has raised a hand. So Puneet, yours.
Yeah, thank you. Thank you, Professor, for a wonderful presentation. My question is that, okay, the benefits of using machinery are clear. It's really helpful and farmers would benefit significantly. It's evident from your research. My question is regarding the costs. Now, how costly is it to hire or buy harvest machinery? Can an average farmer afford them? Do the financial benefits outweigh the costs of hiring or buying such machinery? And if yes, what is the return on investing in such machinery? Because if the benefits are really that profound, why is not everybody doing it? And how can we get more people to do it? So how can we subsidize the use of these machinery? Have you thought about those things? I'm curious to get your insights on that.
Okay. Thank you for your question. Well, that's kind of very important background about the mechanization process in China. In the last 20 years, actually, China's central government has subsidized or heavily subsidized the purchase of agricultural machinery. Typically, the percentage of subsidy accounts about 60 to 70% of the total price, okay, of the machinery. So basically, farmers who could just partially pay for that. So it's kind of not that kind of expensive. And that's the first background. And secondly, because most of farmers in China or in the last couple decades, still the smallholder farmers dominate the farming practices. So we observe that it's the purchase of agricultural machinery is not those smallholder farmers. They are the commercial service providers. So in details, they purchase those specialized farmers purchase the machinery with heavy subsidy, and then they provide the social service or harvest service to those smallholder farmers. So from one region to another region. Okay, like for example, from south to north regions. So basically, farmers, smallholder farmers, could only pay for small money for getting those service. So basically, they don't have to earn machinery. They just buy the service or social harvest. Mechanized harvest service. Okay, that's. I think that's my answer. Thank you. That's a really good question.
Yeah, thank you. May I ask a small follow-up question to that?
Sure.
What is the penetration rate of the adoption or the use of these machinery among smallholder farmers, for instance?
Well, I don't really have the data. I could say most, because for the I didn't show the data, right? I think right now for the machinery rate for wheat and rice and even corn are more than 90% for the mechanized harvest. So
wonderful.
Yeah, most of them.
Well, thank you very much.
Yeah, thank you.
So Professor Yi, so there are some questions in the chat area. You can see them.
Oh yeah. MS can reduce the yield loss risk. However, utilizing mechanization mean more costly. Oh, sorry. I think.
Yeah, that's a question I think related to Puneet's question.
Yeah, Professor Lee, you can also choose to read the question so everyone can hear it.
Okay. Yeah.
Okay.
So
okay.
I think that
I try to answer the first one. However, utilizing mechanization mean more cost and need more effort to farmers' technology adoption. This may be barrier for. I think this question is similar as like the first
Puneet's question. Yeah.
Yes. The second one, such interesting. Okay, I am curious on one thing, and this is related to mechanization as mentioned in your presentation. Is there any issue of the sustainability of using fossil fuel related to mechanization? Well, it's hard to say that. No, well, it's kind of a balance. If we want to balance the environmental issues and also the labor loss or migration issues. I could say, if you face the hungry society with no food, or nobody want to plant food, they all migrate to urban areas, and then, well, I think the fossil fuel use, the driving the environmental cost is affordable. Okay, but actually, we have another project. We have another project to measure the total greenhouse gas emissions through fossil fuels in cropping of China. Actually, that takes minor part. Actually, most of the greenhouse gas emissions from agricultural production is from the in cropping pattern, mostly from nitrogen use, not the fossil fuel. It's very, very minor. Okay.
Thank you. So we still have some time before the next presentation. So I welcome anyone to give more questions. It's a good opportunity.
I think we started early, right?
Yes, we started early. Yeah. I was saying,
yeah,
that,
okay, probably I can ask another question.
Yeah, go ahead.
Yeah, okay, so in your regression, have you considered the variables such as regional GDP as a control variable? Do you think that the regional GDP will also affect the dependent variable?
Well, no, we didn't, because we control the time fixed effect, and also we interact. Well, I don't think we interact that with the provincial level. Well, I don't think I. Well, what's the reason for the controlling for the regional GDP?
Yeah, because regional GDP can reflect the economic development level in a region. And in regions with different economic development levels, probably the usage of mechanization might be different. Yeah, that is my concern.
Okay, yeah, okay. So that's kind of interesting, because if we see that the regional GDP could lead to different mechanization level, then it has been fully captured by the mechanization level, right? So we don't have to control for GDP. Otherwise, that could the coefficient for mechanization level is not the true level, a true impact, because some parts of them has been captured by GDP.
Yeah, great. Okay, so I have another small question. So in China, for rural households, they can either buy machinery from the market, that is a household-owned machinery. They can also buy machinery services from the market, that is outsourcing of the machinery service. So in your analysis, did you distinguish the differences between household-owned machinery and outsourcing services? Because for these two types of machinery, they may have heterogeneous effects on crop yield or yield skewness.
Yeah, that's right. So we expected to do that, but unluckily we don't have this kind of data, because the observation period is kind of very, very long. We don't have such a long observation panel. So basically we don't do that because of the shortage of data for household level, whether to record whether they use the machinery service or the from purchasing machinery. So but from the heterogeneity analysis, we actually try to split a sample based on the highway densities. So well, that could be partially answer this kind of question, because if the highway density is high, and then for the possibly the transportation of harvest machinery from one region to another one might be easily. Okay, if the highway density is low, then it means the cost might be very high, and then prevent the transportation. So basically, I could say that I could imagine that yes, your perspective is definitely right, but from our current research, we cannot fully understand that, but just provide some potential explanation or evidence to show that might be different. Okay, thanks.
Thank you.
Thank you. So so we still have 5 minutes. Actually, I have a small question that So I know you used the panel data. So of course, I'm from finance background, so maybe my question is not directly linked to your field, but just in terms of methodology, that I'm curious to know in your panel, if you have previous year, the area has a natural disaster. So for this year, would the use of mechanic machinery will increase or decrease? Yeah, I was thinking this question will, for me, I want to know is, I was thinking if in last year there's a natural disaster, it could be the farmers doesn't have enough money to continue to use that. But it's also possible that because of the disaster, they're more likely want to improve their crop yield this year. So I'm not straightforward about what way they will go. So I just asking in terms of methodology, have you thought about that? Or you think it would be an interesting question to answer?
Well, it's kind of, it's out of my our expectation, because we think that these to buy the service is kind of very it's not that it would not take that much of money, even they face the crop failure in the last year. Consider that the farmers, more than 50% of their income is from all farm work. Okay, so normally they don't heavily depend on their agricultural production income. So even they have faced with the heavy disasters in last year, so they still have plenty of savings. Okay, think about that. The the saving habit of Chinese people. Okay, so they basically can take advantage, can mitigate those risk impact by themselves. So I don't think that really matters for our estimation. But I think your suggestion is kind of very interesting, and we try to think more about that later. Okay, thanks.
Yeah, thank you. So I think that's all for this keynote speech. We have a lot of questions, and I believe Professor Yi addressed them adequately. So let's move to the paper presentation. So now I would like to introduce our first presenter, Dr. Wei Yang, senior lecturer in Lincoln University, New Zealand. And Dr. Yang specializes in applied economics with a focus on agricultural economics and environmental and resource economics. The paper she will present today is Are We Ready to Transit to Sustainable Production? Analysis of Transition Intention and Sustainable Tools Adoption of the New Zealand Sheep Farmers. Dr. Yang, yours now.
Okay, so I'll share my screen. Can you see my screen?
Yes.
Great. Right. Okay. Thanks, Chair. Thanks, Zhaohua, for introducing me, and thanks for the organizers to have me for this presentation. And on behalf of all my co-authors, I would like to present the paper as introduced by Zhaohua. So this is a part of a project of my master student, Gemma, and we just developed this paper based on the data that Gemma used for her master's degree study. So some background about this study, if you don't really know very well about New Zealand agriculture and the sheep industry. So New Zealand now is one of the top 5 countries with highest greenhouse gas emissions per capita among the OECD countries, although we have this image of green and clean, but based on the per capita perspective, we are a big emitter. So there are about 50% of greenhouse gas emissions in New Zealand come from agriculture. And so the New Zealand government has adopted a lot of new policies in pressing the transition toward the vision of a net zero transition or net zero emissions by 2050. So under the circumstances, there will be definitely more challenges for farmers in the agriculture sector to seek value improvement while at the same time they are asked to reduce environmental impacts. And now New Zealand possesses sizable potential biological resources with a competitive advantage in livestock production, but we do have a fragmented government approach, and the agriculture industry, especially farmers, they had little financial access and support from innovation, and there's little production public disclosure around the bioeconomy, and the sustainable assessment can cover a broad range of issues or practices. So the context of that sustainable transition and assessment can be broad, and then farmers, they might face the personal constraints and challenges in practicing the sustainable agriculture toward that sustainable transition. And so this makes the understanding of farmers' intention of attitudes and willingness to understand transition very crucial for New Zealand if we are going to transit into a full functional bioeconomy. When looking at the literature, the majority of the existing literature have focused on the dairy industry in New Zealand. Sorry, I don't think that do you still see my screen?
No.
I think that I have
No,
to
I couldn't see your screen.
reshare that again because something popped out.
Yes,
about
I
now?
can see it.
Okay, great.
Yeah.
All right. So in the New Zealand context, even though the sheep industry is a major contributor to the primary industry from an economic perspective, the sheep farmers, they are found to be more concerned and aware of sustainable products. But many of the existing studies have focused on the dairy industry rather than the sheep industry. And most studies have focused on a specific tool or certain types of technology or good management practices. But the sustainable transition, they might need a comprehensive set of tools, good management practices that can be fit into the purpose of environmental, social, and economic sustainability. And so in this case, agricultural sustainability tools, they probably help farmers to overcome personal and practical restrictions in implementing sustainability transitions. And here in our study, sustainability tools refer to a wide range of assessment approaches, matrix indicator systems that have been developed in both economics, business management disciplines to measure sustainability outcomes and the impacts across the environment, social, and economic pillars of sustainability. And those sustainability tools allows farmers to collect objective information for their decision-making process toward sustainability transition. And farmers, they might have more control given those sustainability tools and flexibility in their grazing and pasture productivities, farming management practices to gain more knowledge, competence, and confidence. That leads to the research question of the study, that the reduction in sheep industry under the requirements of sustainability transitions might shed light on the question of, are New Zealand sheep farmers ready to transform into the bioeconomy yet, given all the challenges and the potential sustainability tools provided by the industry and the government. So we aim to assess the intention of sheep farmers to adopt sustainability transitions and how the behavior of connecting sustainability information moderates the relationship between sustainability transition adoption and the use of sustainability tools. And the paper is based on the theory of plant behavior, and we try to employ the information collected from the New Zealand Sheep Farmer Survey, as I said, by my master student Gemma, to investigate their motivation, awareness, and readiness for adopting sustainability transitions. So here's the theoretical framework, and based on the theoretical framework, we have developed a few hypotheses for the empirical analysis. So the plant behavior, the theory of plant behavior based on the assumption that individuals' attitudes, the subjective norms, including social influences, and perceived behavior controls, we call it a perceived control, contribute to the intentional intention to adopt sustainability transition, and that will ultimately affect the behavior of using the sustainability tools and the information connection. Based on the TPB, the theory of planned behavior, we have further developed the components and the main variables based constructs and variables based on the key components of the theory that I was showing you. The attitudes, subjective norms, and perceived behavior controls. Here, for example, for attitudes, the original TPP is including behavior, beliefs, and based on our case, we further manifest variables from the decomposed TPP, and we use perceived usefulness of the sustainable tools and ease of use to further extend the TPP. And so that could help us to customer that place a high value on sustainable products and the trust in using the sustainability tools. And following the same logic, we developed injective norms, descriptive norms for the category of subjective norms based on different types of variables. Also, perceived behavior control that includes self-efficacy, that is a confidence level to carry out particular behavior based on individuality, and a perceived control over the behavior. And that could be further developed into 3 variables in our case. I'm not going to go for many details in this case. So here is the real conceptual model and how we developed a hypothesis of the study. We assume that the attitude, subject norms, and perceived behavior control would have an impact on the sustainable transition intention. So that is the hypothesis from 1 to 3, and then that will lead to their real adoption of sustainability tools. Here you can see that we assume that sustainability transition intention would also affect farmers' behavior of information connection on the sustainability information, and that will make information connection a moderator on the relationship between the intention of sustainability transition and the use of sustainability tools. So the empirical models and used by this study is based on the theory of planned behavior. We follow the typical way of using the principal component analysis methods, PCA, to determine the common factors with each TPP constructs. Well, as I showed, attitudes, subject norms, and perceived behavior based on the variation in the data. So PCA has been treated as a really good methods, validated methods to analyze interrelations among variables and determine the constructs developed by TPP, relying on the similar underlying dimensions. And PCA also allows to determine common factors based on the variation in the survey data. It can also reduce multi-observable variables into fewer dimensions of interest latent variables, which are our constructs. We further use structural equation modeling to do the empirical analysis to verify the several hypotheses that I was showing you. So the SEM considers 2 models. The first is the measurement model, which shows how the measured variable represent constructs. And the second model is structural model that estimate the correlation between different constructs, which are the SEM estimations. And the model allows any interrelationships presented in the proposed model to be estimated, and a set of hypotheses like what we developed here can be tested simultaneously. So it is really fit the purpose of testing the validity of the predictive empirical model developed in our theoretical framework that are relevant to effects of attitudes, subject norms, and perceived behavior control on the intention. And this is a well-developed model having used by a lot of existing studies that has various indicators to measure its goodness of fit. The data, as I said, is based on the interviewing sheep farmers across New Zealand between August 30th and September 8th in the year of 2021. And the survey is based on Quadrix software that can be accessed here by the link if you're interested in. So the final survey yielded 583 responses where with 180 partially completed. And so after screening and cleansing the missing information and erroneous data, there were 238 observations used for the empirical analysis. So some empirical results to share with you. So here is the results that shows the goodness of fit of the constructs that developed in the TPP. So as you can see here that I'm highlighted, the KMO test results show that PCA is appropriate for SEM analysis, so for the further empirical analysis. And the ballast test results confirm a strong relationship between the variation of the TPP constructs. So that means that all the constructs developed by our theoretical frameworks are validated. By looking at the principal component analysis, we also find the Krabash-Alber alpha indicator shows a validated information. So based on the criteria and indicators of the TPP constructs, that we can further develop in the TPP constructs into 4 constructs. So the first one is what we proposed. The difference is only the second one, the normative belief. So the subjective norms, we further developed that construct into normative beliefs priority and normative beliefs pressure. So the first one is whether the pastoral industry and New Zealand see this sustainable transition as a priority or not. And the second one is how farmers feel the pressure from the industry and the society. And you can see that all the indicators that I'm showing you here, Alpha-Bach alpha data value, they're all over 0.5, confirming the validity of the factor measurements. So the empirical results also show a considerable goodness of fit. So this is drawn from the empirical analysis that shows us the GFI and CFI indicators. They are all around 90, 93 and 91, and they are all greater than 90.9. So that shows a considerable goodness of fit for this empirical model. So when looking at the results, we can see that for the hypothesis that we developed, there are a few hypotheses that did not supported by the empirical analysis, and the red highlights the supported hypothesis, like this one, hypothesis 2.2, that the priority affects the priority of the industry and the priority of the New Zealand affect farmers' intention of sustainable transition. And the control, the behavior, the perceived behavior control also contributed to the farmers' intention of adoption. And then their intention will further affect their sustainable, their use of sustainability tools. So this is a really strong support for us to understand the good intention leads to the real behavior change, which is the real adoption of sustainability tools. And also the information of sustainability data also contribute to the adoption of using tools. And for the hypothesis 7, the mediation role of information connection, that has not been found to be having any moderation or mediation role on the relationship between the intention of sustainability transition and the adoption of sustainability tools. So to conclude about the discussion and the findings, we can see that the perceived behavior controls and subjective norms based on the priority of New Zealand government and the pastoral industry significantly drive the sustainability transition intention for New Zealand sheep farmers, which means that there might be some support or some pressure that farmers are feeling from the industry and the society that leads to their intention of the transition. And the transition intention further leads New Zealand sheep farmers to adopt sustainability tools. So we find a positive connection between the good intention and the real adoption of sustainability tools. But the behavior and also we find that the behavior of connecting sustainability information has a significant positive effect on the use of sustainability tools, while no mediating effects, as I said, between the good intention and the real behavior change, the use of sustainability tools. And one thing that I would like to highlight is about attitude behavior gap in the TBB model toward New Zealand sustainability transition intention, means that farmers' good attitudes toward transitioning into sustainability might not affect their intention significantly. So this might be due to the constraints of the strong influence of the perceived behavior control.
I'd like to say your time is almost up. Can you really wrap
Yes,
up
I'm
in
just
30
having,
seconds?
yeah, just
Okay.
just have the one last conclusion. So due to the constraints of the strong influence of perceived behavior control and priority subject norms, all the intentions might be, all the real adoptions or the good intentions are driven by the pressure and the priority from the industry and the government, rather than driven by their good attitudes. So that needs our attentions. Thank you very much, and thank you for Zhaohua for your kind reminder. That's all my presentation. Questions are welcomed. Thank you.
Thank you. So you got my text message saying to remind you the time, right?
Yes.
Okay. Okay. So now I open the floor for not open the floor, but I would like to welcome for our discussant, Dr. Yoko Mariono from the Diponegoro University, Indonesia. So Yoko is an economist specialized in rural and agricultural economics. So Dr. Mariono, so can you please discuss this paper? Thank you.
Thank you, moderator. Yeah, may I share my PPT, please? Yeah. Okay, can you see the PPT? Everyone?
Yes, I can see the screen, but not your PPT. I can see you open the Explorer folder.
Yeah, so can you now, my PPT clear from there?
Not your PowerPoint. If you have two screens, maybe you have to share one screen. Oh, okay. So there's a file shared from Dr. Wang Ningma through the chat message. And also now we can see the, your PPT. Yeah, it's showing. Yeah, thank you.
Yeah, so thank you for the presentation. The title, we are ready to transmit the sustainable production. Yes, this is the important topic, yeah, for the sustainable in the SDG era. Yeah, let's discuss the paper. Yeah, first I'd like to comment the introduction section. Yeah, this section is fine. Yeah, because it mentioned problem behind the study related to the sustainable resource efficient. Yeah, and the New Zealand livestock industry. Yeah. Yeah, I show that this section is supported by relevant reference to make the background of the study is very adequate and robust. As also contained reference as a review literature, even though it's merged in the introduction section. Yeah, from this point, the paper is okay. Then go to the theoretical framework. Yeah, the paper uses a theory of plant behavior, yeah, the TBB, which is fit in the objective of the studies. But I found that this is quite unclear, particularly the logical relationship, yeah, among variable considered in the model of analysis in the figure 1. I think the paper need more explanation, more explanation, justification on the relationship among variable used in the analysis. For example, in the construct one, in the one variable can affect the another variable. It's need logical justification why the variable can influence another variable based on the theory. It could be a theory, economic theory, could be a behavior theory. To make the clear, to make clear the relationship. In many studies, using structural equation modeling, SAM, everyone can make many or every model, but it should be supported by a strong theory, because when someone make a model and run based on the data, the number will be there. But what is the meaning if there is no theory behind the relationship? This is my critical point in this theoretical framework. Then go to the methodology. The use of SAM is fit in with the objective of the studies. One of the shortcoming of the SAM is the use of Likert scale, for the sustainability indicator, for example, for the other variable, particularly in the latent variable, because latent variable should be justified or should be indicated by the exact scale, exact measurement scale, not the Likert scale. Likert scale is very subjective. It's mean that the scale, for example, one farmer mentioned the scale is 3, it could be different when other farmer also mention the same scale, but the intention, the meaning could be different because it's very subjective. But if we use exact indicator, for example, number, it will be the same measurement. For example, I give for example a human capital. Human capital is a latent variable. If the farmer can just what is the level of the kind variable, human capital of the variable, maybe farmer just say 4, other farmer say 3. But if we can indicate it with a number, for example, the level of education, the age, how long the experience in the farming, it will be exact scale. This is the one of drawback in the using SAM in this studies. It would be much better to use number related to the sustainability and other variable. Result indication and conclusion. This is also fine. For the studies. The results discussed comprehensively by comparing and contrasting with other findings of the previous study, and the conclusion was drawn from the analysis. Maybe for the recommendation, recommendation it need to be mentioned in the practical step. Practical step. So what should be done by the farmer or also by the government to achieve the sustainability. The last one, the paper need to state the limitation associated with the use of the Likert scale in the analysis. I think this is my point from the paper. Other things is okay. It's good paper, and thank you for the time. I will give back the time to the moderator.
Thank you, Dr. Mariano. So, Wei, do you have anything to respond?
Yeah, sure. Thanks, Dr. Mariano, for your valuable comments and your suggestions. I believe that based on your comments, we will definitely have our paper improved. So some of my comments or response to your suggestions, for example, the first one is about the logic relationship between the variables that we developed. So that needs to be based on the theory. Actually, the the main theory of the development of the constructs are all based on the theory of plant behavior. So they do have a really clear structure about different variables and different constructs. Followed by that, we have developed the variables based on the specific constructs. And we can see that, or we can say that the more depth theory might be based on the psychological behavior model. So, or the attitudes, perceived control, behavior control, and the social norms, they would affect the intention and then further affect the adoption. So these are more from a psychological behavior perspective. So if that could, but we can definitely specify that a little bit more in the theory framework. And then for the next question about the Likert scale, yes, I mean there are definitely limitations for the Likert scale in terms of the development of variables. The one response that I can get is because of the psychological background of this theory of plant behavior, we do many of the variables introduced by this theoretical model and then followed by the empirical variables. Most of the variables are based on Likert scale, so based on the existing studies. And it will be definitely great or even better to really find the exact indicators to describe those variables. But in reality, in practice, it is really hard to find a real sustainability number or indicators to describe human beings' behavior or attitudes or the perceived behavior or the social norms or pressure. So it's usually very subjective questions to ask them about how do you feel the pressure from the government from 1 to 5, for example, using Likert scale. But I think it is fair that we should highlight that in the conclusion as one of the limitation of the Likert scale, even though we might not be able to address that in the empirical analysis, but it is a limitation for us. So I will definitely improve the paper and add some more discussion about the limitation of the Likert scale. Thank you very much.
Yeah. So Wei, you have a question from the chat box. Question from A1. So her question is about the attitude. I think the variable in your model, that is the previous study shows the attitude becomes significant and strongest toward intention. But in your study, attitude is not significant. So
thanks very much. Yes, very good question. And this is actually something that we would like to highlight from our results. So this is something that are different from some of the existing studies. I mean, not all the studies find a significant support from attitudes and good intention. But so this is what we call the attitudes intention gap. Or sometimes there is an attitudes intention behavior gap. Means that good attitudes may not specifically lead to good intention or the real adoption. So the reason behind that is probably because of the other drivers, other main drivers for New Zealand farmers. I mean, this might not be applied across the world. So this might be different from other countries or other farmers in other countries or even other industries in New Zealand. But so this also provide a gap probably for the policymakers in terms of how we could address this attitudes intention gap and trying to really use the good attitudes from sheep farmers to drive their good intentions. But the results that we found is that probably the sheep farmers, they are more driven by the pressure, the social norms, the perceived good behavior control, and that leads to their good intention and then the real adoption. Hope that I answered your question. Thank you.
Okay, thank you, Wei. So that's good Q&A time, and I just follow the schedule. The time is up for the first paper, and I have to move to the second paper. Okay, so the next presenter is Ms. Yunqi Chen from National Taiwan University. Her expertise is in environmental resource and production economics. So the paper she will present today is Economic Effects of Organic Agriculture in Taiwan, assessment based on the major components of the cropping system. So Ms. Chen, now it's yours.
Okay, let me show my screen. Okay, can you see my screen?
Yes, I can see.
Okay, hello everyone, I'm Yunqi Chen, and our topic of our research is to evaluate the economic of organic agricultures. And here is our author team. First, I want to make some introduction for our topics. Nowadays, discussion of sustainable food production system has been more and more popular in the world, and organic farming has been viewed as one of promising farming practice in this trend. Among various organic farming practices, the most essential one is to excluding the use of chemical or synthetic fertilizers or pesticides in crop productions. And there is an emerging trend to promote organic farming in policies. However, farmers will tend to adopt organic farming when it is beneficial for him. So the effect of organic farming become an important issue. It has been many empirical studies evaluate the effects of organic farming from two major perspectives. One is from environmental and another is from economics. In our research, we focus on the economic effect. In past studies, they often look into the effect on production level, cost, or profits. And most of these studies found that organic farming is in general negatively associated with the output level, but show mixed effects on cost or profit from various country studies. And we show some example below. And in our research, we also want to evaluate the economic effect of organic farming. Then how does this research feature? First, we consider four major components of cropping systems. As Liu and Basil mentioned, a cropping system should be composed of four major components, including climate, genotypes, management, and soil. In past studies, we reveal they often look into only one or two of these four key components. So in our research, we will examine the economic effect of organic farming with controlling for all of these four major components. Second, we use agriculture census data, which is large-scale national data. Third, we consider for a special cluster of organic farming. The special dependence of organic farming has been found in past studies, and this special dependence may indicate knowledge, awareness, or technology spillover. So in our analysis, we will compare the treatment effects between hotspot and non-hotspot groups. And the hotspot here means for the special cluster. Fourth, we will do analysis under homogeneous and heterogeneous assumptions. The heterogeneous here means for the treatment effects of organic farming may differ depending on some factors like land scale, farming experience, and so on. In addition, our research can provide an empirical evidence for small-scale farms because most of farms in Taiwan are small scales, and this is where our data. The main data we use is agriculture census data in 2015 in Taiwan. And in our research, we only focus on rice farms because rice farms takes the largest share in all farms in Taiwan. Totally, there are about 213,000 rice farm households used in our analysis. And we also control for weather condition and soil productivity. The weather data we use is in township level, and there are 358 towns in Taiwan. We control for average township, average temperature and rainfall. And because rice farms in Taiwan usually plant twice in a year, so there are two rice growing seasons. One is from March to June and another is from July to November. And we divide each growing season into two periods according to the heading time. In addition, we also control for variation within each growing season. In soil productivity, we use a score from 1 to 10 with the 1 to 10 with the lower score means the higher suitability for agricultural cropping. In addition, we also control for another variable, which is average township income. And we use this variable to measure for the consumption ability in the township. And here is the descriptive statistics, and the outcome variable is economic performance, and we use three kinds of it: sales revenue, cost, and profits. In average, sales revenue is around $5,255, and cost and profits takes around half of it. In our sample, there are about 4% of rice farms adopt organic farming. And the definition of organic adoption is no any use of chemical fertilizers or pesticides. And we control for the characteristics of farm operator and household members. In our sample, we see farm operators are mostly male and they tend to be older, lower education level, less on-farm work day, but they has more experience. In household members, we found gender, age, and education level are more evenly distributed. And in average, there are less than one farm workers in a family. The farm worker here means for the member takes farm work as their main job. When look into weather conditions, we can find temperature and rainfall vary before and after the heading time. Like in season 1, we can see temperature is lower in before heading time. But in season 2, temperature is higher in before heading time. Also, we can see the rainfall here. The rainfall is higher in before heading time in both these two seasons. And the soil score is about 8.09 in average. As we mentioned before, we consider for the special cluster of organic farming, and we use Lisa analysis to find special clusters. From this special analysis, we can test whether there are special autocorrelation between towns and its neighbors. And we can draw a map here. And the red region with high region level, this means the towns has higher adoption rate surrounded by neighbors with higher adoption rate. So this red area is the special clusters of organic farming. And we can also call these clusters as hotspots. From this map, we can see hotspot located in northern and eastern Taiwan. And this pattern is similar to the hotspot regions for adoption and intensity in another study in Taiwan. And when we estimate for the treatment effect of organic adoption, there will be endogeneity problem if we just run this regression like this, regress economic performance Y on organic adoption D with control for other covariates, including farm operators and household members characteristics, seasonal weather conditions, and soil productivity. In our return, there are some unauthorized variables like attitude for environment, risk aversion, and they are correlated with organic adoption, so lead to endogeneity problem and makes an estimation bias. So we use IV method to solve the endogeneity problem, but there is another problem because organic adoption is a binary treatment. It will be not efficient if we just use traditional IV with two stages are both OLS. So we use the method called probability to save square method, which is introduced in several studies and we used in like add-on studies. We can see this method as a three-step approach. In the first step, we run a probability regression, regress organic adoption on instruments with controlling for other covariates, just like we mentioned in the previous slide. And the instrument we use here is the leaf-out mean of organic adoption rate in the township where the farm household locates. So from this first step, we can get a probability of organic adoption. And we use this probability into second step. In the second step, we run a OLS regression, regress organic adoption on probability with control for other covariates. And from this second step, we can get predict organic adoption, DI hat, and we can use this DI hat to the third step. In the third step, we run a regression which regress economic performance by predict organic adoption with controlling for other covariates. And alpha measures the local average treatment effect. So this is our empirical method. And let's show our result and some discussions. In the first part, we evaluate the economic effect of organic adoption without considering the special clusters. We can find that the coefficient in three kinds of outcome variables are all negatives. In revenue, it might suggest that the price premium cannot cover the reduction of output level. And in cost, we can see the reduction in the cost is likely due to the cost reduction from cutting the use of chemical fertilizers or pesticides. And the most important for the farmers is the profit. This result indicates that the organic adoption might lead to a negative effect on farm profitability by around $867. In the second part, we compare the treatment effects between hotspot and non-hotspot groups. So this is a subgroup analysis. In our expectation, we suppose that the clustering can moderate the economic effects of organic adoptions. So these are our results. In revenue, we can see sales reduction is lower in hotspot groups. This might indicate that the farms in hotspot area may face a better price premium of organic products. And in the cost part, we can see cost reduction is lower in the hotspot groups. So this might indicate that the organic farms in hotspot area are more willing to invest on their organic farming. So the cost reduction is lower. And in the profit, it's a promising finding that the coefficient is insignificant. This might indicate that organic farms become competitive with conventional farms in this hotspot area. In the third part, we show the heterogeneous average treatment effect. This means treatment effect is correlated with the deviation of farm from the whole sample in variables except for the treatment. And this method is also introduced in several studies. This also means average treatment effects are not the same in each individual farm because in each individual farm, their farm characteristics are not the same. So we draw a graph with average treatment effects on y-axis and farm characteristics in the x-axis. From this graph, we can find that average treatment effects vary with land size and the numbers of hire workers. We can see in the left-hand side, as increase the land size, we can see average treatment effects first decreasing and then become increasing. So this is a nonlinear effect. And most farms locate in the decreasing part. In the right-hand side, we can see the increase of numbers of hired workers, the average treatment effect become higher. So the filter sign are positive slopes. But when we look into some characteristics of farm operators, we found very mild effects on the average treatment effects from this graph. So we can see the filter lines are very flat in the age exclusion or like other characteristics. So in conclusion, we found that organic adoption makes negative effect on economic performance. But when we consider for the special cluster of organic farming, the clustering lowers the negative effects on economic performance, especially in profits. Furthermore, under heterogeneous assumption, we found average treatment effects varies with the farmland area and the numbers of hired workers. So these are our the main finding of our research. So,
okay, thank you, Ms. Chen. So now I would like to welcome Dr. Hongyun Zheng to discuss your paper. So Dr. Zheng is from Huazhong Agricultural University, China. He works in the fields of agricultural economics and development economics. So Dr. Zheng, I welcome your comments on Ms. Chan's paper.
Okay, thank you, Professor Li. Thanks for your introduction, and also thank you, Yunzi. Thanks for your excellent presentation. And I really enjoy reading your paper because I learned a lot about organic agriculture in Taiwan. And so here is my comments and suggestions for your manuscript. So based on your excellent presentation, I would also wanted to emphasize some highlights of your manuscript. So this study analyzed the impact of organic agriculture on sales revenue, cost, and profits. And in the introduction, you mentioned 3 contributions. First is estimate the treatment effects with controlling the 4 major components of cropping systems, and especially you employed a large sample size. Actually, it's really hard to find a study using such a large sample size in the literature. And the second is you investigate the spatial patterns of organic farming. And third is providing the evidence for small-scale farms based on the household survey data in Taiwan. And here are some comments and suggestions. Well, first is about the title and abstract. Well, I didn't find the abstract in the PDF file. And as for the title, well, you mentioned 4 major components, right? It's climate, genotypes, management, and soil. This is related to their first contribution. But my question is, and the 4 components is only mentioned in the introduction. For example, in the table, the appendix 1 and tables 1 and 3, it is better to use the subgroup title, for example, the climate-related variables or soil-related variables to reflect the 4 components more clear. And I did not find the key literature to support the 4 components, Liu and Basel 2020. So I suggest you to check it. When I read the title, I thought that 4 major components may be related to the key treatment variable or outcome variables. But here, I think the 4 components are all related to control variables in the estimation. But the question is, including more control variables may not affect the relationship between treatment variable and outcome variables in the linear regression. So the contribution to the existing literature may not be significant. And the second contribution is associated with the spatial patterns, spatial agglomeration. Well, if it's important part of this manuscript, it is better to reflect it directly in the title. For example, the title should be Economic Effects and Spatial Patterns of Organic Agriculture in Taiwan, right? Because I saw your mention in the presentation that the investigating the spatial patterns is used for the heterogeneous analysis, but I'm afraid that it has no direct correlation with the topic, the economic benefits of organic farming, right? And a small question is about, you mentioned that the climate condition and soil qualities may vary across different locations, but I'm afraid that in Taiwan, in such a small locations, climate change varies or not. You should make it clear. For example, some data or figure to support your discussion. And the third is about the small-scale farms. Well, I suggest you to compare the farm scale with other regions and rural areas to highlight the contribution 3. And the second is the data and the sample. Well, I think in your presentation, the outcome variables are measured as total revenue or total cost and total profit, but I'm afraid that it should be measured as, for example, revenue per unit of land, for example, per mule or per hectare, because the total revenue cannot be compared across different farms with different skills, right? And also, I mentioned that I noticed that in your presentation, the organic farming is defined as no use of chemical fertilizer or pesticides. So is the no use of fertilizer and pesticides or all pesticides? I think you should make it clear, right? For example, if the farmer used chemical fertilizer, but organic pesticides or organic fertilizer and chemical pesticides, so it is organic farming or not. And as for the empirical method, well, I thought that you constructed IV. Well, it's great, but the question is, it should be tested by a formal IV test, for example, a falsification test. And for the spatial analysis, you just mentioned that you use the Lisa analysis, but if it's a major component of your manuscript, it is better to introduce more about this method in the method section, right? And also, you only use common boundaries to construct the spatial metrics. So if you should compare it with other methods. And then the results and discussions. Well, one question is, well, it's okay to find a negative impact on sales revenue, cost, and profit. And you also gave some explanations in the manuscript, but still wondering of the reasons of why the organic farming brings no economic benefit or negative effects on farmers' performance, right? So if the findings are negative impacts, what are policy implications? For example, should we encourage farmers not to adopt the organic farming because it could bring no economic benefits? So this is question. As for this, I suggest you to conduct more heterogeneous analysis. So currently, your findings towards age, for example, age, education, gender, and farming years shows no significant heterogeneous effects across farmers with these characteristics. So maybe the findings would be different if you conduct more heterogeneous analysis. So, I mean, we should find why, in general, organic farming shows a negative impact, but in some way it may have a positive impact. So that would help us to obtain valuable and practical implications for policymakers. Otherwise, a negative impact told nothing new, right? So some minor comments, especially for the introduction section. Well, first, I suggest you to provide a systematic literature review, because the literature is mentioned in several paragraphs here. For example, you discussed the contribution 1, then literature, contribution 2, some literature. So it is better to provide a systematic literature review and then list or discuss the contributions of your manuscript clearly. Well, after reading your introduction, I can find some contributions, but it is better to list them clearly. For example, the first contribution, well, first we contribute to the literature by doing something, right? So that's all my comments and suggestions for your manuscript. I hope this would help you to improve the manuscript further. Okay, thank you.
So thank you, Dr. Zheng, for your very detailed and insightful comments. So Ms. Chen, would you like to respond? And I just a reminder that you have 4 minutes left, so it has to be really quick respond, and then we will see whether there's any question from the floor.
Okay, thanks for the good suggestions. And as we compose of 4 major components, but some researcher may show insignificant. But in our research, we show some like weather conditions or soil productivity. They show some significant coefficient, and in our subgroup analysis may show some insignificant and significant between these different groups, and this might implies different results, and we will expand more clearly in our research, and we will check it in our further work. And the heterogeneous effects in the third part of our results, and we will try to show more farm characteristics and show some more result of that. And I think and you as you mentioned, we didn't we can say more clearly in our introduction and say our contribution, and I will check it and will make it better. And because of time, I think if we are co-author Professor Du has some to say about suggestion. Hello, Professor Lu.
Okay. Yeah.
Thank you, discussion. And I just have one point to add. There is a question about what's the definition of organic farming in this study. Actually, we use the definition that there is not any use of synthetic chemical inputs. So this will include both fertilizer and pesticides. And there is another question about weather conditions. Actually, previous studies, we find there is some spatial distribution from the north part of Taiwan to the south. So there is actually weather condition variations in the data. So I just want to add these 2 points. Thank you.
Okay, thank you. So I'm really mindful of the time. So I would suggest that if you have further questions, you type the question in the chat box. Make it clear so this question is to Ms. Chen, and then Ms. Chen can reply to you. I think that will be really good. Okay, and then we can move on to the next paper. Okay, so basically you can still do the Q&A through the chat box. Okay, so the third paper we have in this session is from Dr. Yunpeng Li, who is from Huayin Normal University, China. So Dr. Li specializes in agricultural economics with a focus on agricultural infrastructure, rural environment management, rural informatization, and rural development. So the paper is titled with Promoting Sustainable Agro-Food Production to Achieve Food and Nutrition Security, the Role of Soil Conservation Practices. Dr. Li, yours now.
Okay, thank you, Professor Li. And I'm going to start share my screen. And can you see my screen?
Yes, I can see.
Okay, thank you. Okay, let's start my presentation. And hello, good morning, everyone. This is Junpeng Li from Huayin Normal University, Huai'an City, Jiangsu Province, China. It's a great honor for me to present our new research titled "Promoting Sustainable Agri-Food Production to Achieve Food and Nutrition Security: The Role of Soil Conservation Practices." My co-authors include Puneet Vatasa, Wang Lingma, and Feng Liu. Okay, as we all know, more than 800 million people worldwide are experiencing chronic undernourishment, and over 90 million children under 5 are underweight. Food insecurity remains a concerning problem, especially in developing countries. Since the global population is expected to rise to around 10 billion by 2050, existing effective strategies such as improved agricultural inputs, for example, organic fertilizer, GM varieties, and agricultural practices such as zero tillage are far from achieving the goal of food security. Therefore, more efforts need to be made to explore more effective strategies. As we all know, soil quality is vital for improving crop yield, which could then increases farmers' income and food consumption. Accordingly, it's essential to investigate the impact of soil conservation practices, SCPS in short, on food and nutrition security. Accordingly, the objective of our study is to investigate whether and to what extent soil conservation practices impact food and nutrition security in the context of China. By doing so, we contribute to the literature in two fronts. First, we provide the first impact to analyze the association between SCP adoption and the rice yield. Previous studies have integrated SCPS with the study of agricultural conservation practices, and or have focused on one and another practices of SCPS. The former may overestimate the effect of SCPS, and while the latter may underestimate them. The second, we analyzed how adopting SCPS changes dietary patterns of households. Previous study have focused on the household total household food consumption, or the amount of total caloric intake, which cannot provide detailed information on the patterns of household intake. We analyze the SCP adoption, analyze the impact of SCP adoption on a range of 10 specific food consumption of rural China rural households, which could enrich our understanding of the association between SCPS and household nutrition intake patterns. Previous studies have documented that farmer decision to adopt improved agricultural practices such as SCPS could be influenced by observed and unobserved endogenities. And there are multiple empirical strategies have been developed and widely used to address endogeneity issues. Generally, they include the PSM, RPWRE, endogenous switching regression model, and the endogenous treatment regression model. Among them, the PSM and the RPWRE approaches can only account for observed endogenities, while it cannot address unobserved endogenities. The ESR model can address both observed and unobserved endogenities, while it cannot generate the direct impact of the treatment variable on the outcome variable. In comparison, the ETR model can not only account for observed and unobserved endogenities, but also determine the impact of SCP adoption on food and nutrition security. Therefore, we use the ETR model as our primary empirical strategy. The ETR model contains two stages. The first stage describes the farmer's decision to adopt SCPS by regressing a probit model. And the second stage of the model estimate the impact of SCP adoption and the other control variables on household food and the nutrition security by regressing OLS model. Maximum likelihood approach is employed to estimate these two equations, and the correlation between the two error terms in the two equations points to the presence of unobserved endogeneity. To guarantee the ETR model is well specified, a valid RV should be included in equation 1, but not included in equation 2. This study selects pro-environmental knowledge measured by a 5-point Likert scale from 1 equals very little to 5 equals very much of the household has as RV. Prior literature shows that households associated with environmental knowledge and perception tend to adopt pro-environmental practices such as CPS. Therefore, the selected RV is supposed to be positively correlated with the treatment variable. Meanwhile, the RV cannot directly affect food and nutrition security, but why its impact on the treatment variable. Therefore, we argue that our selected RV is theoretically valid. To further build the admissibility of our RV, we further conducted the falsification test. The result in a table A1 suggests that our RV is correlated with the treatment variable, but uncorrelated with the outcome variable. Therefore, our RV is valid and reliable. The data analyzed in this study were drawn from the 2020 China Land Economic Survey, a Jiangsu province targeted survey sponsored and conducted by Nanjing Agricultural University, Nanjing, China. After data cleaning, a data set comprising 830 observations on rural household used in our study. And of these, 134 reported adopting SCPS. SCP adoption is our treatment variable, which is defined as dummy. Specifically, this variable equals 1 if the respondent reported the adoption of at least one SCPS among soil remediation, commercial organic fertilizer application, and formulated fertilization, and zero otherwise. Our outcome variables include rice yield and a vector of specific food consumption, which include rice, pork, beef, poultry, fish, egg, bean products, vegetables, fruits, and vegetables oil. And rice yield in our study is measured at 100 kilogram per mole, and the specific consumption is measured at kilogram per capita per day. Table 1 present definitions and descriptive statistics of the selected variables. And table 2 presents the main differences in the selected variables between SDP adopted and non-adopters. Generally, SDP adopted and non-adopted are systematically different from each other. However, the significant mean differences in table 2 cannot be referred as the impact of SDP adoption on rice yield and specific food consumption, because it doesn't control the impact of a vector of control variables. Therefore, we will rely on a more rigorous empirical strategy to correlate the impact of SDP adoption on food, on hospital food and nutrition security. Table 3 present our main result derived from the ETR model. As can be seen, SDP adoption, the variable of primary interest, exerts a significant and positive impact on rice yield. Specifically, SDP adoption can increase rice yield by 7 percentage points. And meanwhile, we can also observe that rice yield is positively and significantly associated with education, old ratio economic status, soil fertility, plot slope. The ETR model also generates the determinants of SDP adoption. It suggests that SDP adoption is positively and significantly associated with education, real estate ownership, risk averse, farm size, plot slope. And while it is negatively and significantly correlated with the past infestation, a proxy of negative shocks. We also estimate the impact of SDP adoption on specific food consumption. The result in table 4 suggests that SDP adoption can increase the consumption of pork, fish, fruit, and while it can reduce the consumption of rice and vegetable. Generally, SDP adoption can increase consumption of fruit and protein-rich food, while it can reduce the consumption of rice and fruit, vegetable. We also confirm the robustness of our main results by conducting a two-stage prediction inclusion approach. The result in table 82 suggests that SDP adoption exerts a significant and positive impact on rice yield, which is well consistent with the result we derived from the ETR model. Therefore, our main result derived from the ETR model are reliable and robustness. Here we come to the conclusion and the policy implications of our study. Our study examined the association between the adoption of SCPS and rice yield. Mitigating soil degradation is important for protecting the environment, and improving rice yield can contribute significantly to alleviating food insecurity, as rice is the most common staple food globally. Meanwhile, we also explored the impact of SDP adoption on farmer nutrition intake patterns. Using an ETR model to estimate the 2020 CLES data, we show that the adopting SCPS is associated with a 7% increase in rice yield. As for the relationship between SCPS and dietary compensation, we find that adopting SCPS is response to increase in the consumption of fruit and protein-rich food, such as pork, beef, and bean products, but with a reduction in the rice and the vegetable intake. Our study also provides significant policy implications. First, awareness programs should be designed to spread awareness of SCPS in rural communities, because we find that SCP adoption can increase farmers' rice yields. Second, government may move forward by providing financial assistance to facilitate the transition to SCPS, because SCP adoption could be cost intensive for rural farmers. Third, promoting formal education in rural areas should be an integral part of any agricultural policies, because we find that education has positive and a significant impact on both SCP adoption and rice yield. And the fourth, different change management practices may have to be implemented to mitigate the adverse impact of negative shocks on SCP adoption, because we find that pest infestation can hinder the farmers from adopting SCPS. Okay, that's all of my presentation, and thanks for your time.
Okay, thank you, Dr. Lee. So now I would like to welcome the discussant, Annie Kadikasari from Lincoln University, to discuss your paper. So Annie is our senior lecturer, and she is also the director of the UNES Center for Social Businesses. Okay, Annie, so your time to discuss the paper. Thank you. Hello. Annie, I think you muted your microphone. Annie, you have to unmute your microphone. So can the,
okay.
yeah, okay, I can hear you now.
Yeah. I'm just going to share my screen before I start talking. Let me organize it. Where is it? Screen 3. Okay.
Yeah, I can see it.
Okay, I can see it. Let me see. Yeah. Thank you very much for the opportunity to discuss this paper, and congratulations for such an encouraging result from this research. I like to eat rice, and the result is for your research. It's great to share this encouraging aspect. So what I like to do is that adopting SCPS is associated with an increase in the consumption of other protein as well, which is really really good. So the affirmative answer is, as I said, is very encouraging, and because of that, this is obviously a result of a very well structured and very clear motivation of this study. It is highly relevant for the 3 main reasons that I listed here. Firstly, the concern all over the world on the soil degradation and the effects it has on the ability for our society to produce food, and especially in rice-growing countries, which is most of Asian countries at least. And thirdly, the study is important as it considers the multifaceted conservation practices, the soil remediation, commercial organic fertilizer application, and formulated fertilization. All of these are quite technical in my view, and getting farmers to adopt to this various and complex practices is not a small challenge. And previous studies have regarded SCPs as part of an array of climate smart agricultural practices, or focuses on one practice at a time. So, but this study extends the literature in this regard, as it take up several factors as in the equation. And because there are so many SPCs that farmers can use, it's important to consider several practices at once and see which which one is stronger and which one needs to be work more. And my comments on this paper is that the authors have addressed the indigeneity of adopting SCPs, and this is important, and well done for having done well to recognize that this adoption is indigenous, and not addressing it will result in biased estimates and limited application elsewhere. So what I like to comment here is that although the literature review is up to date, I must point out that it's too extensive, and the key studies can easily get lost in the amount of literature that is cited. The data for this paper were collected in 2020. Does the information pertain to the same year that is presented here? And if the information only pertain to 2020, then the data may not represent how farmers react in ordinary circumstances. We need to remind ourselves that 2020 marked the beginning of the pandemic, and that things might change in terms of the ability and willingness of farmers to adopt those practices. Also, growing rice in different regions can be different. You know, I'm not sure if the geography is all the same, flat or steep slope area. And I wonder if the authors have anything to say about how the practices may affect rice production in different areas from Jiangsu, where the case is focused. So I would like to see how these findings specific to Jiangsu could be applied to other areas with different and similar growing condition. And I would encourage the authors to dig deeper into the production side of growing rice to throw out more meaningful comparison. The authors discuss the climatic condition in different areas of Jiangsu, and I'm curious as to what difference are there in the production across these different regions. Are they climatically identical, geographically identical? And even if the adoption of the SCPs does not vary regionally, it might be worth discussing why the yield does not vary across different regions within the province. Okay. So two other areas that I think it's need further investigation is that how might the scientific advantages in rice production interact with rice production? Will we need different SCPs? Should better and more resilient rice varieties become available? For example, in science or in agriculture are inextricably linked. And this paper does not say anything about how fluid this interaction and how the interaction might affect the adoption of CSPs. So those are my comments. One other comments as a practitioner in rural development, I said is about costs. In your recommendation is to get government to help, which is good, but it's not always doable. I was thinking of how might the farmers be encouraged to learn from each other. You suggested formal rural education, but farmers learn from each other through field schools, for example. Would there be more effective in the fact that often government supports are limited and very lengthy to come by? Thank you very much for the opportunity and to comment, and again, congratulations. Thank you.
Thank you, Annie. So, Dr. Lee, would you like to respond to Annie?
Yes, yes. Thank you, Professor Annie, and thank you, Professor Lee, and thank you, Annie, for your valuable comments and suggestion. And we believe your valuable comments and suggestion will improve the quality of our manuscript to a very high level. And I want to respond to some of your comments and suggestions because of the time limit. First is the comments about the citations. Yes, we will reduce the citations and keep the key studies in this field. And the second comment is for the time of the survey. The survey is conducted in 2020, and we want to clarify is the information referred to the production in 2019. Yes, we will clarify in our manuscript in the following steps. And yes, there are significant differences on the distribution of the because the spatial disparities. We control 3 region dummies represent the northern, central, and southern Jiangsu to reflect the impact of spatial disparities. And we also control 2 variables that are the past infestation and post-lobe to control the impact of geographic factors. Yes, I think our study have controlled the impact of geographic differences. Yes, we as present we only analyze the impact of SCP adoption on rice yield and nutrition for only 1 provinces because the 2020 CLES data only conducted in Jiangsu province. In the future, we will do further studies beyond 1 provinces. And thank you, Annie. Thank you.
Okay.
Okay, so now we will open the floor for questions. So you can either type or you can just raise your hand or just ask you in the voice. Yeah.
Yes, I can see a question from the box.
Go ahead.
Thank you for your explaining about what kind of soil cultivation is in your study area. Yes, as we all know, there are multiple soil conservation practices in previous studies, such as soil remediation, organic fertilizer, and zero tillage, and the rational use of pesticides. In our study, we only considered 3 most commonly used in China. 3 practices are most commonly used in China. They include soil remediation, commercial organic fertilizer application, and formulated fertilization. Thank you.
Okay. More questions? We can do 1 more question. We have 1 minute left.
Yeah.
Yeah, Yoko.
Yeah, thank you, the chairwoman. Yeah, it's interesting paper. You talking about the food and nutrition security, but your focus in rice production, right? Is there any relationship between the increase in the production of rice with the nutrition security? Can you explain it? Thank you.
Sorry, Professor Yuko, I didn't catch your question because your voice.
Yeah, you're talking about the food and nutrition security, right? Using the conservation of the soil. Yeah, but your focus in rice production, usually rice only to make the food secure, but not for the nutrition. Do you have any explanation or justification why you put the nutrition security in this aspect?
Okay.
Thank you.
Because we think, as you know, soil quality is the a fundamental factor besides the machine labor for to the agricultural production, especially for the rice production. And rice production is served as the fundamental element of food security, because rice is the most stable food globally. So we want to analyze the relationship between soil conservation practices and rice yield to explore more effective a more effective strategy to fight for food insecurity. Thank you.
What was the relationship between the nutrition, because you mentioned also nutrition security as well?
Sorry, could you repeat it?
Yeah, for the rice is okay because this is for the food production and food security. But for the nutrition security, is there any relationship?
You mean the motivation?
Nutrition.
Yes.
Nutrition. Yes. As we noted in our manuscript, the increase of rice yield could bring farmers more agricultural income and more food consumption. Therefore, we argue that the adoption of SCPS could improve farmers' nutrition intake patterns. Thank you.
Yes, thank you.
Okay,
thank you.
That's good. So if you still have questions, you're welcome to type your question in the chat box. So I believe Dr. Lee can answer that. I think that comes to the end of this session, and you will move to a short break, I believe. So before I conclude, I would like to thank all of the presenters, keynote speakers, and discussants, and all the participants. So, and I want to stress that you probably don't know how much effort the organizer put into this conference. So I want to give thanks to Professor Wanning Ma. So he's really dedicated to this conference and spent a lot of efforts. And I also like to give thanks to the third discussant, because of the change, a very sudden change of one of the discussants. So Annie has to step in to read the paper in less than 24 hours and give comment. So I really appreciate Annie's effort. And because as a chair, I can see some of the stories behind the scene. And I really amazed by the work ethics of the discussant and presenters. And you probably wouldn't notice that the first presenter just gave birth to a baby boy 5 days ago, but she still chose to present this paper to stick to the program. So this is really high work ethics. And so I wish to really say that as a chair, I didn't do much, but I'm really touched by those behind the scene stories, and that motivate the academic career. So I believe you all enjoyed a very good intellectual feast on these topics, and you deserve a short break. And then I hope you can come back after the break. That's the end of today's session. So I'll back to the moderator, Johnny.
Thank you, Dr. Lee. Sorry, my name is Kiki, not Johnny. Okay. Thank you to Dr. Lee, keynote speaker, presenter, and discussant for your excellent performances. And we will have a break up to 10:50, and then we can run to the second sessions afterwards. I think you can enjoy your break. See you again. Welcome back to our sessions. Continuing to the next agenda, I would like to invite Professor Alam William Brentwick, which is a professor in agricultural economics of Faculty of Agribusiness and Commerce, Lincoln University, New Zealand. He has been professor of agricultural economics at Lincoln University since 2015. Prior to moving to New Zealand, he worked in academic institutions in England, Scotland, and Ireland. A main focus of his work has been the impact of agriculture, environmental, and trade policies on the economics of land use, and he has published widely in this area. He has undertaken extensive work for governments and industry bodies. Recently, a key focus of his work has been on the economics of existing and novel land uses and the process involved in land use transformations and adaptations to climate change. He is also currently co-chair of the Lincoln University Center of Excellence in Transformative Agribusiness. To Professor Brentwick, time and screens are yours.
Thank you very much. And thank you for the kind introduction. It's a pleasure to be here today to chair the second session in this virtual international conference on promoting sustainable food production, challenges, practices, impacts, and solutions. I think we've got four really interesting papers in this session, and I'm really looking forward to hearing them. Before we start, I will emphasize to our speakers, please keep to time, and we will do our utmost to keep to time with 15 minutes for the paper and 10 minutes for the discussant. So we will endeavor to keep the session to time to make sure everyone gets a fair allocation, and that we keep to the time within the conference. So I won't take up any more time. I will pass on to introduce our first speaker. And so the first paper in this session will be assessing smallholders' heterogeneity towards sustainable agri-food value chain in developing countries. And we're very pleased to welcome Dwi Hidiati, hopefully somewhere near her name's pronunciation, who's a PhD researcher at Massey University, but also is a lecturer in the agribusiness department at the University of Trunojoyo, Madura, Indonesia. So she has two roles, but we're very looking forward to hearing your presentation. So we have biographies, which hopefully you will have, so you'll be able to read those. I won't spend the time going through the biographies because I think it's more interesting for us to hear the speakers speak. So Dwi, it's over to you. Thank you.
Yep, thank you very much. Now I'll start my screen. This one. Can you see my screen?
Yes, it's just coming, I think. Just yeah, that's it.
Sorry, wait a moment. Why I can't make it? Why I can't see my own screen?
Oh, you need to go onto presentation mode too for us, I think.
Yeah. Wait a moment. Sorry for the technical things. I will stop share for a while. Sorry. So I can't see my screen.
All right, because the share worked.
Can you see it? Okay, so
yeah, we can see it.
Okay, now I'll start.
If you set for presentation, we should be fine.
Okay, so
it's okay. We're a little ahead of time, so you're fine. There's no rush. We're good. Yeah.
First of all, thank you very much for the British Food Journal and Brawijaya University for providing me the opportunity to present our paper today in the international conference. And our paper, as mentioned before, entitled "Sustainable Assessing Smallholders' Heterogeneity Towards Sustainable Agri-Food Value Chains in Developing Countries." So I have outlined a 6 key agenda for today's presentations. I will start with introductions and then followed by literature review. After that, next will be methodology. And the last 3 sections will cover about the results, discussions, and the conclusions. So Please allow me to start with the introductions. And well, probably everyone in this conference have realized that there's a growing demand for the sustainable products everywhere, especially if we are talking about a high value market and global value chains. So yes, sustainability is everywhere. And this issue has affected smallholders in developing countries. And because smallholders are the key players in the value chain of developing countries, and they are increasingly moving into the high value market in the search of greater income. Economic reasons probably behind of these value chain transformations, and in many cases, these transformations serve as the poverty reduction strategy. But let's see what's happened in the high value market. The high value market, they require all the value chain players to adhere to the sustainable standard practice, in which they want to balance the economic orientations with a more like social and environmental aspects. So it's going to be very challenging task for the developing countries to transform, because first, in the developing countries value chain, smallholders are a large number. Probably some studies mention over 500 smallholders over there, and they are heterogeneous. Furthermore, they face various issues, lack of capacity, lack of skill and access. So the key question is, who are the smallholders? They can act as enabling actors, and actually what are their character, so that they can be compatible with this high value market. Given this background, so that's why our study aims to empirically assess the heterogeneity of the smallholders in the sustainable agriculture of developing countries. And we believe that this paper could contribute to the advancement of the knowledge, especially to understand the typology of smallholders as the key players for the sustainable value chain transformations in developing countries. Furthermore, we believe that this study would provide some how we can allow for the more targeted and prioritized interventions towards sustainable value chain practice, which is probably beneficial for the policymakers and also the practitioners. So now let's discuss about what are the relevant literature review about this issue. Because the agri-value chains discussions has increasingly sparked the idea how to incorporate the sustainability practice into the value chain itself, because the sustainability concepts is actually recommended since it is aligned with the food security goals in terms of sustainable productions and consumptions. Well, of course, there have been so many studies in this area of, let's say, how to enable these sustainable value chain transformations. Given this previous background that I mentioned to you. However, we found that majority of this research actually continues to be dominated by farm-focused improvement. In the meantime, many studies also we found that farm improvement activities often lead to the risk of the environmental and social deteriorations. Let's say, for example, smallholders, if they would like to improve productivity, they tend to put more fertilizers, chemical fertilizers, and apply deforestations and also exploitations. So that's why, for more effective sustainable value chains, Hidayati et al. In 2022, actually, in your screen, now probably you can see that we need to structure more the enabling factors that have been provided. Yes, farm practice should be equipped with information communication. They are still the strong factor. However, since the key of the successful of value chain is integrations, it must be there must be a secondary factor to help with these three factors: stakeholder support, certifications, motivations, and market expansions. And another thing, to make a complete sustainable value chains, so we need to create more values. Although this part actually still become the weak factors in developing countries, we need to improve more pre, post-harvesting value and also value capture. However, regardless of various factors that we found, that has been found, actually there are still big questions. Is that how is the perspective of smallholder regarding this? Because mostly they may not uniformly respond to this matter. So that's why the technique to develop smallholder practice must be cluster specific. So it's critical to see the heterogeneity in terms of their perspective to move into sustainable value chain. And probably it's not also enough, because we need a subsequent of the profile of the, to see their profile in terms of social, economic and kind practice in order to see the underlying cause of their behavior. And in the end, we need to do, based on this, we can put recommendation based on this age group characteristics. So yes, I use this framework to develop for our study. So about the methodology, we applied a quantitative method in Indonesia's cashew sector in 2021, and why Indonesia cashew sector? Because this is our map. So Indonesia, around 99.8% is under smallholder farmers for the cashew productions, and over 70% of the product goes to the global market. And in particular, we select so many regions here because it's the main cashew producer area, and there was a cashew belt program there in 2014, and also this is very close with the export-import facilities. We have collected around 159 respondents, and we did face-to-face interview under very strict pandemic protocol. And a sequence of analysis was applied here. We use cluster analysis, one-way and offline cross-type analysis. So here we come with the results. Our results for the general characteristic of samples we explained by using two, the socioeconomic and the kind practice. In our farmer characteristics, surprisingly, that over 60% are female. So there is, in the future, there will be, for the female sector development, probably cashew sector could be one of considerations. Mostly they are productive age. However, it's just general issue that they are less educated, probably up to primary or 6 years old. 6 years in education, sorry, and then, but they have a really over decade experience. It means that they have vast experience for over a decade, and most of them are non-members of farmer group, and this is not surprising because actually in their the farmer group membership based on the mixed farming farmer group base. So, because it's related to the farm characteristics, well, over 60% of the farming characteristics are mixed farm, and only around 30% are single cashew farm. And average total productions, we use per tree per year, which is in average around 40.2 kg per year. Next, about the kind practice, it's represented by productions, marketing, and certifications and coordinations. But in overall practice, productions and marketing are generally practiced by the smallholders, but mostly they ignore about certifications and coordinations. Now here comes with the next results. We try to cluster them by using these 8 enabling factors, and the distributions of each cluster is actually a bit comparable, over 20%. And we can see there are some color blue means the strong factors, as I earlier mentioned. And then there is a pink factor, it's for the moderate or the secondary factor. And the green is for the weak factor. And we name them as accelerator, conservative, inattentive, and progressor based on the value that we result. Probably the next one will provide more clearly. The accelerators is represented by the blue color, in which they are on the outer side, which is the highest intention towards sustainable value chain. And then it's followed by the orange one for the progressor. It has a good intention, but not as much as the accelerator. And then the inattentive, after that, the last one is conservative. And I would like to direct your attention into the pre-harvesting value activities, where it used to be a weak factor, but however, the attentive and the conservative group is really interested in this matter. And I'll let you know why. Sorry, this is a bit crowded slide, but yeah. So we tried to see their profile again based on the socio-economic and the kind practice. And the socio-economic, we found that the accelerators actually has the highest profile in terms of socioeconomic conditions. They are more educated farmer, they have the highest productivity, and they have the largest farm size, and they practice in most of productions and marketing activities. Meanwhile, for the progressor, surprisingly, it comes from the profile, which is the not so educated farmers are there, and also the farm size is a bit lower, and also they have a but their current practice is really good, but although only their farm size and their educations are still not so in the good conditions. In contrast, inattentive cluster comes from some of those who are educated family axis, and they have a large farm size, but they ignore more on the productions. That's why they have a lower production. They have a low productivity in this case because they ignore most of the productions, but they have a best price in this for the selling of their product. And lastly, for the conservative, is they have the least socioeconomic conditions in terms of education, in terms of fund size, and in terms of productivity. Also, they have a least activity in terms of the current practice. So to synthesize all our research, actually we try to arrange and prioritize how these 4 cluster groups can be reorganized. So the most progressive one is the accelerator. So we believe that it should be the most prioritized groups, and because it has the funds towards sustainable value chain intention and also has the highest socioeconomic and current practice. And the next with the progressor, because it has the although it has a limitation in terms of socioeconomic and in the socioeconomic particularly, but it has a really, it can be more, they can be inspired more to adopt more sustainable value chain practice. And the last 2 groups, the inattentive, probably the third priority because it has a good asset, but however, it has a low intentions towards sustainable value chain. And the last one, conservative group, needs a really extensive interventions in this case. If the interventions is successful, the inattentive may move into as accelerators, and the conservative cluster may move as the progressors. So, yeah, based on this, we would like to briefly summarize that actually by identifying the smallest typology is really useful. We can see how they can be prioritized, and this can provide a groundwork for effective interventions based on their characteristic. And finally, we can address more limitations in the future for the future research, like probably cashew could be different from other sector like paddy or whatever it is. Probably Madura Island cannot represent all the developing countries or the overall Indonesia. And lastly, probably because it is smallholders perspective based, alignment with other value chain players could be very useful in the future explorations. Probably that's all, and thank you very much.
Sorry, thank you very much, Dwi. I finally unmuted myself. Thank you very much, and thank you so much for keeping such good time. We now have opportunity for our discussant. Our discussant today is Omphili Timoso, who's an adjunct fellow in applied economics at the University of New England Business School in Australia. And he will discuss Dwi's paper for 10 minutes, and then we will have an opportunity for other questions if there are any. So Omphili, over to you. Thank you.
Yeah, thanks, Alan. Thanks, Dewey, for an interesting paper. And thanks to organizers for inviting me to come and contribute to the conference. Yeah, so I won't repeat the title of the paper because Dewey has done good justice providing that title, and also I'll just move on to the next slide. So the objective of the paper was to investigate smallholders typology, sustainable value chain practice of developing countries. The study used data as a case study for the cashew sector in Indonesia. There were about 159 respondents, and in the Madura Island. As Dewey pointed out, there was a few different types of methodologies that were applied: descriptive statistics, cluster analysis, cross table, and one-way ANOVA analysis. In terms of the results or the key contribution, they found that there were 4 groups that were identified. Each of those groups had distinct characteristics, which were arranged in priority using the signal graph that Dewey represented. So this included accelerators, progressors, inattentive, and consecutive groups. In terms of the contribution of the study provided better understanding on how to identify actors who are more aligned with the demands of high-value markets and being able to prioritize them in order to move forward and transform them into sustainable value chains. I got a few things. As I've mentioned, the studies in most cases is clear, and there was hard to pick a lot of things there that they didn't address, but I only picked up a few things. One of them is in terms of the introduction. You talked about the sustainable value chain practices, but I feel like it might be good just from the introduction to just highlight what do you mean by sustainable value chain practices, because not everyone knows, because there's many different ways you can define what is sustainable practice. So it might be good to highlight in the introduction what that refers to. And also, I looked through the paper, even in terms of the data or the descriptive of the respondent. I couldn't see, like in terms of where did these farmers sell their products, because you're talking about value chains and who are other actors in the cashew value chain in Indonesia. So it might be good to highlight that somewhere also in the study. And the other part is the 8 enabling factors. I saw in figure 1, you did show how they look and also try to explain it in the results. But I feel like it might be good also within the methodology to just highlight, like expand on what does the 8 enabling factors implies, how do they differ? Also how other studies might have considered them in the other studies and what did they find? And so, yeah, just another small thing. You might be good to cite on the line 37 and 38 on what you, because you have this statement about smallholders are the key players in the value chain in developing countries. I'm sure Indonesia, it might be different from sub-Saharan Africa, and so they're all developing countries. So it might be good to either highlight that it's in Indonesia or actually cite other sources which have provided this statement. And yeah, this other comment, when you presented today, I realized that it's probably, you probably decided that you're going to include that in the paper because you already have a map that you presented in the paper, in the presentation today. So this comment might not be relevant today. Just other small things. Yeah, I was wondering, why did you consider one-way ANOVA? And then also, did you test your data to see if it's normally distributed from, because from my understanding, one-way ANOVA can be applied if the data is not normally distributed. So maybe you can just clarify that. And then, yeah, the other part is just line 37 to 35. You might want to break that paragraph in your paper. And one more last thing, like in your paper, you talk about the title of the paper is Developing Countries, heterogeneity, and then you talk about developing countries. So when I looked at the paper, the title, I thought maybe you have data sets covering farmers from across different developing countries. Or so you might consider about the title is either you still leave the developing countries and then maybe put something case study from Indonesia. Because when I looked at it, I was thinking, yeah, you're covering like a broad, different farmers from different, developing countries. And also in terms of the literature review, you might want to expand if there's any other studies that have considered those eight enabling factors. I feel like you might want to highlight those ones because that might emphasize your contribution of your paper, at least in the developing countries context. And just one more last question. So what are some of the type of intervention that you, from your perspective, might be implemented to enable some of those 4 groups of farmers? That's all, thanks.
Thanks, Omphili. Thanks for a very comprehensive look at the paper and some questions you raised. Perhaps before we open up for wider discussion, Dwi might like to respond and comment. Obviously, she's only just seen these, but I wonder if there's anything that comes to her to respond initially.
Yeah, first of all, thank you very much for your very valuable comments. Yeah, first of all, this is a series of our PhD research, so this is our last paper actually. And yes, about the introductions, yeah, we thank you very much for that very valuable comment. We will try to complete what is still missing in that issue. And probably about the methodology, we have checked about we combine one-way ANOVA and cross-type analysis, actually, that's something that we use for the profiling. So we tried, because the one-way ANOVA worked well for the numerical data, and some are categorical data that we use cross-type analysis. But yeah, I will emphasize more in the methodology, why we need to use one-way ANOVA and how is the distributions, normal distributions should be addressing this issue. And then about the empirical findings that we found, actually this is what we feel, that actually there is still limited study in here, because most of smallholders heterogeneity is actually more addressing in terms of their farm practice improvement. In the meantime, in our side, we try to go with the overall, we try to shift the lens of the sustainable value chain lens, where we put not only fund sustainability, but also in the governance and value addition side to see the overall picture. So that's why there are some limitations in terms of the previous study that we found. So, but yes, we will try to gather more information to see whether how it can be contrasted with probably the we try to re-update again what's happening for the current situations again. But so far, that's why when in the literature review, we mentioned that there are some previous study that has been there, but actually we need to complete them by using our study in this area. And then secondly, about the type of interventions, actually in our paper, we have emphasis for that. For example, in the accelerators, the most, because they have a low price compared to this inattentive and this conservative, we try to intervene them into like a value-adding activities rather than to, because they already have a good productivity. We would like to intervene more in terms. You should change the way you sell on the raw material. Probably they can more either shell nut or processed nut. So the same with the progressive for the progressors. Meanwhile, for the inattentive and the conservative, probably they can we can provide more intervention in terms of the farmer group membership, so that it can give them more insight how to improve together as a cooperative and the cooperations more, and they can get more information, more training through accessing this kind of memberships. So probably I cannot explain to you in one by one here, but yes, I believe we have put it in our paper, but probably we can't emphasize more how to see that each cluster should be intervened in, what kind of intervention that can be done differently, and what kind of interventions that can be done together, I mean, among these groups. Thank you.
Yeah, thanks.
Thanks, Dui, that's great. Do we have any other questions? It's a little hard for me to see whether, you can either put them in the chat, or please maybe just unmute yourself, because I can't see all of you at once. So if anyone has any other questions they would like to ask, please speak now or chat. While we're waiting, perhaps I'll just ask one about those clusters. Again, eyeballing your spider diagram, there didn't seem to be huge differences between some of these clusters, and so I guess I'm just kind of interested in the robustness of the groups you got, and whether there is enough to be able to differentiate them to make these, sort of different policy statements. That's all. It might just be, obviously it's the first time I've seen it and I've just eyeballed it, but it seemed to be you almost had 2 and 2 clusters, where 2 were quite similar and 2 others were quite similar, but the difference within those 2 was quite small, I felt. I don't know.
Well, thank you very much for your comments. First of all, it was based on a Likert scale that we asked perspective from 1 to 5, from the strongly disagree up to strongly agree. About this scale, we believe that we can distinguish that some people are still feel hesitant if they are around 3, and some people can be see their judgment of perspective if they are around 4. Or 5 probably. So in this case, it's really, sorry, where should I start my explanations? Because I try to mix with the second, I try to align with your two questions. Probably I should start with like this. If you can tell the difference between 4 groups, actually the beauty of this paper is those 4 groups actually can have a contradictions in terms of one has the most progressive intentions and it has a really high asset socioeconomic. Another one, there is some smallholders also has high asset, but interestingly, they don't want to move into sustainable value chain. Most of them are hesitant. Most of them, they really don't want to go with the stakeholder support. That's really interesting. Another thing, there are some people with low assets, but they have a high interest towards sustainable value chain. Then the last one, of course, they have low asset and they have no interest. So that's why we decided to keep in this 4 group, and we try to see the phenomena. And probably the scale 1 to 5 is as far as we did this research, that was the best scale that we can see, because 3 can be whether we can't really tell whether they're neutral, whether they don't want to move, or whether they, so we try to see if they is unlikely to move. So far, what we think that this 4 can provide a more contradictive, and we can see how different they are. But yes, if we would like to intervene one by one, it's really difficult. So that's why we try to synthesize that. This is what we got based on that. I'm not so sure. So yeah.
Okay. No, thanks. That's helpful. Yeah. So I have a question from Arif, which is great. He's asking, your results indicate that 100% of farmers have no certification at all. Can you please explain what certification may be beneficial for them?
Yeah, thank you very much. Yeah. This is also an interesting thing that we found at the time. I was expecting at least 1 or 2 experience on this, because it is some of them are for the export oriented, but actually they are non-certified farmers. And about the certifications, probably from the government side, if they can have a support from the stakeholder side, probably we can start with a farm certification, let's say, for example, like GAP, Good Agricultural Practice, because most of the product currently goes to the global market in the form of raw material product. So that's why probably we can start with the farm certifications with the GAP. And in the future, if they would like to go with a more processed product and with more value-adding product, probably we can go with the next level certification for the product, branded, whatever it is. I hope that can answer.
Thanks. I just see there's any others there. Just one last, if you've got a minute or 2 before we need to move on. I guess you've got the 4 groups, and you've kind of got your dials saying how much effort is needed in each group. I just wonder, I mean, there's I guess an effort and reward thing to me, and I'm just interested to think, which groups do you think where the reward would be greatest for the effort that's needed to improve their situation, if that makes sense to you?
Oh, all right. Thank you very much. So for the, I believe you're talking about like the like a speedometer here. That if for the for the accelerators groups, we believe that there's least interventions is required. That's why they comes up with a priority, because they have all assets, they have all the intentions. So we believe that by only little effort of interventions, we can support them fully to move into this high value market, because they have motivations, they have the assets, they have all the capability, but they just lack of something that we need to intervene. And it could be like probably taken less time and take less interventions. And in the opposite, for the conservative, they have lack of asset, lack of capacity, lack of skill, and they do not have motivation. So we believe that more extensive interventions will be required for them. So I wonder whether that makes sense.
Yeah, but do you think those interventions would be worth doing, I guess, is the question in a way? Will there be still reward for doing that for those?
For the accelerators, you mean? Whether it's
well, no, for the ones where you need more greater interventions, you know, you're saying there will be more interventions, but there'll still be rewards from doing that, do you think?
But for me, for us, is that's why we put priority. The first, there will be the last priority. But for me, in my opinion, I think that we need to support smallholder in the best way that we can. We can't leave them alone in that side and just become because it's gonna be like we leave them in the weakest positions. It means that they should be weak forever. I don't think we should do that. So I think in the future, probably each group can support each other by, I don't know, in more developing countries, probably their behavior, like if they see some other farmers are successful, other people can follow their can follow their path. So that's why I believe that it's still worth it, but it takes time, because what we don't want somebody who's left behind in this case. That's what I think.
Okay, no, thanks, Dewey. That's great. I don't think there's any more questions, so perhaps to wrap up this paper, and just like to thank you very much for a very interesting presentation, and to Omphili as well for his careful work as a discussant. So I think we can give you a virtual clap, or as I'm unmuted, I will clap for you. Thank you.
Thank you
well
very
done.
much.
That's great.
Thank you very much.
Thank you. Okay, we will just move on now to our second paper, and I'd like to welcome Hadi Akbar Dal from the Department of Biotechnology in the Division of Advanced Science and Biotechnology at Osaka University in Japan. So welcome, Hadi. We're looking forward to your paper. His paper is on simulation of lockdown policy and varying rate of consumption related to traditional food production of tempeh, I think you pronounce it, a fermented soybean food. So again, he will talk for 15 minutes, and then I will introduce our discussant after that. So Hadi, we're looking forward to your presentation. Thank you.
First, you can see my screen, right?
Yes, yep, that's great.
Yeah, thank you. So thank you, Professor, for introducing me, and thank you for the organizer and the editors for organizing this conference. So I'm going to present my presentation today based on my paper, which is a simulation paper. So it's about lockdown policy and varying rate of consumption of traditional food. So as you can remember, during the peak of COVID, I believe many of us had experienced lockdown in our own country. The lockdown was supposed to reduce the number of COVID cases, but it also had contributed harm to the public health. And also throughout the lockdown, people's dietary habit had changed. People start using the takeout service to meet their food. But I believe that people will surely order comfort food instead of nutritious meals during these hard times. Besides the lockdown, some governments provide relief support to the people. This can be in form of monetary support or even food package support. But the limited supply and lockdown might have led to only less nutritional or only highly processed food being available for sale or given to the people. Usually, food subsidy given by the government or non-profit organization use non-local or global foods. So this leads to the questions: can traditional food business survive the lockdown? Traditional food, local food are supposed to be sustainable because they originated from the local area. Most of these traditional food are labor intensive and cannot be automated. With the lockdown, production of the traditional food, especially the fermented types, dwindled. So for this, let's look at one of traditional food, tempeh. This is the picture of tempeh on the bottom right. And so tempeh is a fermented food from Indonesia and is widely consumed throughout Southeast Asia. It has high protein content and can be considered as a meat alternative. It was considered as a people's meat during the World War II era due to unavailability of livestock at the time. The tempeh industry is mainly a cottage industry. It's normal for several tempeh factories to operate within the same city. Since tempeh is a cottage industry, the tempeh factory relies on human manpower to operate the production line. In this cottage tempeh industry, there is no automation in the production line. So tempeh is a staple food and is easily spoiled within a few days if it's stored at room temperature. As such, the factories need to always be in operation to meet the local demand. So the objective of this paper is to investigate the effect of lockdown order and varying rates of tempeh consumption towards the tempeh production within our community. So this methodology, I'm using a system dynamic simulation approach. These simulation developments involve workshop discussion with system dynamics expert, parameter estimation from literature review, and personal judgment for ease of modeling. So I would like to introduce a bit about system dynamic. System dynamic is a computer-aided approach for strategy and policy design. It's not new. It's been developed by Professor J. Forrester from MIT in the mid-1950s. The main goal of this system dynamic is to make better decisions when confronted with complex dynamic system. This approach provides methods and tools to model and analyze dynamic system. And this model results can be used to communicate essential findings to help everyone understand the system behavior. So for brief introduction, I will show you this system dynamic model of cat population. System dynamic model have a flow here, a stock, and a variable or converter, they call it. So this is a system dynamic model. And we'll be having the model. We can change the variable to see the behavior. Usually we see the behavior of the stock, in this case, the cat population. So if I change the cat birth rate from normal, from 200 to increase, we can see the stock increase. So this is the function of system dynamic. So we map out all the complex network, and once we already map out the network, we can just move a bit, 1 or 2, we can see the result. So for the model building of this development, the model was first developed with the system dynamic workshop conducted by the South African chapter of System Dynamic. So this discussion and model reiteration were done through 6 weekly meetings with 2 expert system dynamic modeler. And at the end of workshop, I submitted the model for appraisal to 2 independent system dynamic modeler. And during the developed model, most of the parameter estimation was based on literature review. And we also discussed and personal judgment were made on certain parameters due to limited information and ease of modeling. And all based on this iteration, revised system dynamic models were used in this study. And this figure shows the revised system dynamic model. This system dynamic model has 3 sections: soybean warehouse, tempeh factory, and tempeh demand. This is each section had 1 stock, and they are connected to other sections via multiple variables and flow. Once we have the system dynamic model completed, we can perform policy analysis. So policy analysis is an examination and evaluation of available options to address various economic, social, or other public issues. We can perform policy analysis on system dynamic model. This is done by adding variables into the system dynamic model. For example, let me based on the example just now about the cat population. So we want to slow the cat death rate. So what we do, we increase the policy analysis here is to increase the number of veterinarians in the area. So this is an example when we increase the veterinarian, so the number of cat death is decreased and the cat population increase. But this is just a simple system dynamic model. So back to my paper just now about the tempeh. So there are 3 types of policy analysis done in this paper: varying lockdown policy, varying rate of tempeh consumption, and combination of 2 above. But because of lack of time, we are going to only focus on 2 types today: varying lockdown policy and varying rate of tempeh consumption. We will only focus on 2 sections only to see the stock of tempeh product and tempeh consumption. Now, let's go to the first policy analysis: varying lockdown policy. Lockdown policy, the impact of lockdown towards tempeh production and tempeh consumption is expected to be severe, but had not been documented elsewhere. In this policy analysis, we model the effect of 35%, 55%, and 75% lockdown restriction against normal condition, which is not lockdown, and full lockdown. The percentage lockdown restriction served to model the movement restriction of essential workers during the COVID-19 lockdown. The value for this policy analysis is based on personal opinion and ease of simulation. It does not simulate an actual lockdown policy because all countries have different implementation of lockdown policy. So for easy understanding, in this policy analysis, I will just varying the lockdown order here from no lockdown control, 25%, 50%, 75%, and full lockdown. And this is the result. The figure A show the tempeh production and figure B show the tempeh consumption. The blue line is the behavior of the system when there is no lockdown. So it's like the control. So as you can see here, there's one line above when there's no lockdown. So this is actually 25% lockdown, and the tempeh production seems to increase. But do not be tricked, because this increase of production is a surplus due to the decrease in tempeh consumption by the local population, as you can see in B. Actually, it's not they become more diligent making tempeh, but it's just not many people eat it. So people will usually assume that a lockdown increase, the tempeh production will decrease, but this model was able to tell that it's not always true and describe why. So this is the one beneficial of system dynamic. Once we already plotted, we don't need to remember everything. We need to think a bit, and then the system will show us. And as for other policy, as lockdown order increase 50 to 100%, tempeh production and tempeh consumption decrease until 0 at full lockdown. Another perspective to observe the effect of lockdown policy is by comparing the data to doing no lockdown. As you can see, at 25% lockdown policy, 3 days are required to achieve the same volume of tempeh consumption. From this, we can imagine that tempeh contact size factory will still be able to overcome the spread of decreased income. But at 50% and 75%, it's take much longer. So tempeh contact size factory will have a drastic decrease in income, especially with 75%. We can assume that the tempeh business might need to temporarily close operation due to negative net profit. This can be seen, the effect can be seen within 1 month of operation. The next policy analysis is the varying rate of tempeh consumption. So traditional foods such as tempeh has a risk of decreasing consumption by the local populace, maybe not in Indonesia, but in other countries. Even though it's in the traditional food, decreasing consumption can lead to decreasing demand and eventually lead to decrease in factory income and closure. One major factor in decreasing traditional food consumption is due to urbanization. In some countries, people tend to increase more Western style diets instead of their local foods. In this policy analysis, we model the effect of no consumption, half consumption, and overconsumption against normal consumption. So this is just a graphical I said just now. So, and this is the result. Again, the blue line shows the control, which is the not blue line. The gray line is showing the normal consumption, the control one. As you can see, in this policy analysis, the tempeh production is inverse to tempeh consumption in the above graph. The number of tempeh produced in A is the highest when there is no consumption. Well, of course, because nobody buy it. At half consumption parameter, the number of tempeh produced is higher than normal and overconsumption. This is because there's less demand for tempeh by the population. The tempeh produced are still stockpiling, but at a lower rate than no consumption parameter. And in this processes, we also have an overconsumption. At overconsumption parameter, tempeh production is the lowest as shown in A. It's because there's constant high demand for tempeh consumption every day. So in this case, we can see that the tempeh factories were limited by the capability to produce more tempeh at overconsumption parameter. This yellow one. So another perspective is to see how many days, this system is to see how many days it takes to reach 1,000 kg of tempeh production. Why I said 1,000 kg of tempeh production? Because in the industry, at least in Japan and I think in Indonesia also, the value of 1,000 kg was set because tempeh factories usually store surplus tempeh at frozen temperatures minus 80 degrees by utilizing a series of deep freezers. And from this graph, as you can see, at no consumption, the freezer can easily full at less than 5 days. While at overconsumption, it takes more than 90 days. So it can never, the freezer can never be full in overconsumption. So as a summary, we can suggest that at low tempeh consumption rate by the population, the tempeh business should reduce the daily rate of tempeh production. If the business is not able to reduce its daily rate of tempeh production, it might need to reduce the size of its business and risk operating with negative profit in the future. As a conclusion, This study utilized system dynamic modeling to simulate tempe factories operating under lockdown order and varying rates of consumption over a period of 3 more months. Based on the simulated model, high station lockdown order and low tempe consumption rate among the population will severely affect the tempe cottage size factory. The model showed that high station lockdown will reduce tempe production and tempe consumption. Since it is a systemic effect, the effect of lockdown order can be seen within a month. This model also showed that low tempe consumption rate can lead to stockpiling tempe. This can guide the tempe factories on what to do next. Maybe if they already have stockpiling, they should make sell to other area or transform it to another product, maybe like tempe burger or tempe chips. Although the simulation is not without limitation, because simplifying many things is sufficient to showcase the impact of lockdown order on local traditional food business. I wish the full paper can be accepted for publication because there are another policy analysis that is not discussed today due to time constraint. With that, I like thank you for listening.
Thanks, Hardy. Yes, it's sometimes hard in 15 minutes to get everything in a paper over, but that was very clear. So I'd like to now welcome our discussant, who's Mohammed Shadiqa Rahman, who's a lecturer in socioeconomics in the Faculty of Agriculture at Brawijaya University in Indonesia. He's there? Oh, great. And he will discuss the paper. So over to you, Shadiq. I think you're still muted, so just...
Hello, thank you very much, Professor Alan, for the introduction, and also thank you very much for Dr. Hadi for your nice presentation. It's very interesting topic. Can you see my screen?
Yeah.
Yes.
Perfect, thank you.
Sure, okay, thank you very much. This research is really interesting, talking about the simulation of tempe production and consumption since the lockdown policy is happened. Based on my observation, firstly, I would like to summarize this research. This research is trying to investigate the effect of lockdown order and varying tempe rates of tempe consumption toward the tempe production within a community. This research also employ a system dynamic model to simulate the association between lockdown order and also tempe consumption and production. The main result of this research is indicate the high restriction lockdown order and low tempe consumption rate among the population will severely affect tempe quoted size, and also the effect can be seen. The effect of lockdown can be seen within a month. Based on my observation, I have several comments. Firstly, coming from the introduction section. From the introduction section here, I found several claims that in this paper that need further substantiating. Some sentence in this paper are not critically engaged with the supporting literature. For instance, I have highlight in my hard copy. I give two example for page 2, line 4, and also page 2, line 11. My suggestion for the sentence, the authors can support the sentence with supporting literature to make the sentence abstract. And also I suggest to check all another section regarding this issue. On the other hand, the second point of the introduction, it's better the author could include some discussion to show that the previous study have shown that the COVID-19 policy, such as lockdown or restriction, is affected the food consumption in general and also food shopping pattern in general. This kind of literature will help you to highlight the research gap and also research contribution. Secondly, my comment for the research methodology. Firstly, in the material and method section, my suggestion is please explain more about the system dynamic workshop that conducted in South Africa. The author can explain more about who are the participants, and also does the participant of this workshop have an expertise on traditional food, especially tempeh. And also, secondly, in page 3, paragraph 4, the author point out that the discussion and personal judgment were made on the selected parameter due to limited information and easy of modeling. My suggestion here is please explain more about the sentence in the term of discussion and personal judgment, and also selected parameter, because such kind of sentence make the sentence is quite weak. For the second section, coming from the model setting, the study has 3 sectors in the dynamic system model, including soybean warehouse, tempeh factory, and also tempeh demand. And each sector has its parameter in developing the causal loop diagram. However, based on my observation, in the current form, the explanation is unclear. My suggestion, the author should rearrange this part by explaining each parameter of this 3 sectors in detail. To address this issue, the author can include the equation for all parameters in the main text, which is currently the author have present the equation in the appendix, and by doing this, the author can provide detailed explanation about the study model, and also the author can elaborate more about the determination of selected variables value and also its measurement. For the next part is result in discussion. Currently, in the current form, the value of the study, I think is little bit is unclear, because the author is still emphasizing what they have done rather than stating the value of the result of the study. My suggestion is please include some discussion about the value of the study findings in each part of the discussion section. Furthermore, for the conclusion section, my suggestion is please further discuss the specific practical application for the tempeh factory based on your key finding, especially for the several countries that produce more tempeh food. And also, finally, I have 2 questions about this research. First is, did the author discuss the study model with the tempeh actors in Indonesia, since tempeh food is originated from this country? And secondly, yes, is also play an important role as tempeh output in the tempeh production for the fermentation process. My question here: do we need to consider this input, namely this, in the study model? I think that's my observation. Thank you very much.
Thanks, Shadika.
Back to
No, thanks, Shadika. That's great, and some interesting comments there for Hardy. Hardy, I'll let you respond first before throwing it open for wider questions. So if there's anything you'd like to respond to those comments, that would be great.
Yes, thank you, Professor. Thank you, Dr. Mohshadik Rahman, for your comments. Thank you for the comments. I greatly appreciate it. I have regarding to your 2 questions. Actually, the author discussed with the tempeh actors in Indonesia. Actually, I was tempeh researcher in Japan, and also I collaborated with Rumah Tempeh Indonesia. So I discussed with Professor Made Astawan from Rumah Tempeh Indonesia, which is an organization that tries to standardize the tempeh making method in the whole Indonesia, but it's quite difficult. So in Indonesia, I discussed with Professor Made Astawan, which is I think the director of Rumah Tempe Indonesia. In Japan, I know the industry because in Japan there's not many tempe makers in Japan. Maybe in Kansai area, for example, in one Kansai area, there's only 2 tempe factories for the whole Kansai area. So yeah, if these 2 factories die, there's no tempe in this region. So I see the system from that perspective. And for your second question, yes, yeast also plays an important role, but that's the ease of modeling part. If I start to put the fermentation rate into system dynamic, it will become too complicated. And during the workshop, they said I actually tried to implement R0, including into the system, but the system dynamic expert says too complicated make the model go wrong. So if you have an objective and try to make the model into the objective, too much detail will make too much complicated and it can easily become fantasy, their word. So that's the ease of modeling description. So I agree with you. Your part. Maybe I need to justify or describe more what is ease of modeling. And as for the equation, yes, I should supposed to share the equation for each model, but actually in the paper itself, I actually share the link to the model, so each people can download the model and try on their own computer. So it's available if it's published. Okay. Thank you again for your question. I already copy the questions, and I will, if I have the chance, I will revise it based on the comments.
Thanks, Hardy, for responding. I have one question in the chat here from Neza from Bravijara as well. I should be able to pronounce this. We deal with them at Lincoln. We relationship with them, so apologize for pronouncing university wrong. They say, I'm very interested in your research since they're a new learner of system dynamics. They're just curious about the lockdown policy effect on production. It seems to be that up to 50% lockdown policy will decrease the production. In that situation, won't the cost per unit increase? The question is, will the cost per unit increase? And will the willingness to pay decrease if the price of tempe is higher than usual? I guess there's some issue about, sort of the price quantity interactions here, and they'd just like to hear about your opinion on this.
So thank you, Neza, for your question. Yes, I believe so. If if the price is down, so people might want to buy it. But implementing, I want to reiterate that my objective of the study is for the production side. So it does not related to the cost side, because I just want to know how tempe are made. So Neza, if you can input it, if you can make it the system, you can input it. But one advice that I still remember from the system dynamic, you can put it, but don't try to put many things in one system model, so else it will be complicated. So if I going to put the price, should only focus on price. If in this case, I only focus on production tempe only. So I apologize that I cannot answer your questions confidently. But I think, yes, I suppose it's true, but it's not within my model's objective.
Right, so there's no interaction of price and quantity going on in the model in terms of affecting the production and consumption. Okay. Oops, I pressed the wrong button here. Any other questions? Oh, let's go here. So I just closed everything to look at the chat. Sorry, Arif again. Please ask your question.
Okay, thank you. My name is Arif from Brawijaya University. In the practical implication for policy, in terms of lockdown policy, you divide the scenario with lockdown 75%, 15 and 20% lockdown. Okay, and then as a policymaker, we want to know, can you imagine or can you describe what is 25% or 50% on 75%? As now, for the full lockdown, we face the close of public area. We cannot go out from home. But what about 50%, 70, 25%, and etc. Okay.
Okay. Thank you.
Okay. Thanks.
So the unit the in this system dynamic model, so I cannot use actual value because this is actually like a made up scenario, not made up scenario, but it's a simulated scenario. So I can try, if I have the data from one country, I can put down the country, but in this case, I'm going to make the model general. So that's why I put as 25% of the population, 75% population. Actually, in the model, if we can put actual value of the 1%, 2%, but I think even in actual policy, it's quite difficult to count, right? So how to count, how to know the essential workers? I think in some countries use the only essential workers can move around with the lockdown. So well, it's actual value. I don't know whether it's exists or not. So it doesn't be published. But in this case, in my opinion, for policy makers, we need to use artificial value to see the result, and then from the artificial value, we can just discuss and make their own judgment, their own discussion and judgment to implement it into a new policy. So that's the actual objective of system dynamic. Instead of just implement a policy blindly, you make an artificial model to see whether your policy works or not. So to answer your case, the 35% and 70% is just a value that I made on my own for easy modeling purposes.
Great. Thanks, Hadi. I think we probably need to move on. I hope, Arif, that answers your question. And obviously quite a lot of interest in tempeh from our Indonesian colleagues for their main dish here. So thank you both, Hadi and Shatika, for your discussion and presentation today. That was great, and we really appreciate it. So now we'll move on to our third paper. And our third paper, our presenter is Siti Dato Musa. I've shortened the name slightly in the middle. Hopefully, it was quite a challenge for me there, but she's an assistant professor of development economics at the UBD School of Business and Economics, Brunei Darussalam. And we're looking forward to her paper, which is about food security and sustainability in Southeast Asia, lessons from the COVID-19 pandemic. And so we're really looking forward to hearing this, Siti, and I'll pass over to you now. Thank you.
Thank you. Thank you, Professor Alan, for the introduction. So yes, you may call me Siti Musa, actually. That's the shortest one. Okay, so I will start my presentation. Can everyone see the screen?
Okay, good.
Yeah, okay, so let me go briefly on the background of my paper. So before I move on to the aims and objectives and the methodology, I will give a brief background on the paper. So the paper is about the impact of COVID-19 on food security in Southeast Asia. So COVID-19 and food security, the relationship. So we can see that the Sustainable Development Goal, especially on SDG number 2, have been emphasized a lot. It aims to ensure that the world population has access to sufficient and nutritious food to end hunger in all forms and achieve food security. And this is through sustainable agriculture. However, the pandemic of COVID-19 has resulted in a drastic increase in poverty and chronic hunger. And it has been estimated in 2020, there is 119 to 124 million people who are rolled back into extreme poverty and chronic hunger. And the pandemic has also resulted in a drastic rise in the prevalence of undernourishment from 8.4 to 9.9%. And the global prevalence of moderate or severe food insecurity has also increased to 2.37 billion people that face food security issues in just over a year's time. And a brief background on Southeast Asia and the agri-food sector. And in Southeast Asia, the agri-food sector is considered one of the top priority sectors as it plays a significant role in the ASEAN countries' socio-economic development. So let's just give, I'm going to give some figures here of the agri-food sector in Southeast Asia. It accounts for over 15% of the GDP in Indonesia, Myanmar, Laos, Vietnam, and Cambodia. And Myanmar's agriculture sector ranked as the highest GDP contributor at 22.3% among the Southeast Asia region in 2019. For the other countries like Cambodia, Laos, Vietnam, Indonesia, the agriculture sector's contribution to overall GDP in 2019, as you can see in the figure here, is 16.7%, 14%, 13.7%, and 12.4% respectively for all those countries in Southeast Asia. And additionally, apart from GDP, the agri-food sector also accounts for more than 30% of Southeast Asia's labor force. And especially for Myanmar, in the year 2020, it had the biggest rate of employment in the agriculture sector at 48.9%, followed by Laos at 45%, Vietnam at 35%, Thailand at 35%, and Indonesia at 29% of their labor force involved in the agri-food sector. And also a brief background on Southeast Asia and the food trade. Thailand and Vietnam are the two largest rice exporters worldwide. They account for 22% and 12% of rice exports worldwide from 2017 to 2019. Other commodities that are traded in Southeast Asia include vegetable oil from Indonesia and Malaysia, coconuts from the Philippines and Indonesia, sugar from Thailand, also pineapple from Thailand and the Philippines, coffee from Vietnam, pulse grain from Myanmar, and cassava from Indonesia. These are the top commodities that have ranked ASEAN as the top 3 exporters globally. Also, Southeast Asia is very highly interdependent on the food trade. So the ASEAN Trade and Good Agreement, or in short form ATIGA, was established to foster the free movement of goods and lessen trade barriers and strengthen interrelationship among ASEAN countries. Also, let me go through some of the brief background on food security in Southeast Asia. Using the Global Food Security Index in 2021, only 2 members out of the 10 ASEAN countries have ranked above the average 64.6 scores. Singapore and Malaysia ranked 15 and 39 globally, whereas the rest of the ASEAN members, they are placed below the average in the GFSI index. So most of the ASEAN countries, they had a score below 50. Okay, this is mostly because under the natural resources and resilience. According to the Economist Intelligence Unit in 2021, exposure to climate change risk contributes to poor performance among countries, especially in the case of Myanmar, the Philippines, Thailand, and Vietnam, where exposure to climate change was extreme. So all these issues, brief background issues, COVID-19 and the importance of Southeast food trade, food security brings me to the paper on sustainability and food security in Southeast Asia. So the objectives of the paper is to evaluate the immediate impact of COVID-19 on food security in Southeast Asia. So the first part of the paper investigate the link between COVID-19 and food security in Southeast Asia. And the second part provides recommendations on sustainable strategies to tackle food insecurity towards a more sustainable food system in line with SDG number 2. So the methodology used for this paper is a systematic literature review. Okay, so the steps are as follows. First, there was a formulating of research questions, and then we locate the materials for review and selection of study and evaluation. We analyze and synthesize the literatures, and then we report the results. So this is just a diagram of the systematic literature review process. So the step 1, when we formulate the research question, there are 2 research questions for this paper. What are the impact of COVID-19 on food security in Southeast Asia? And research question 2, what are the initiatives to tackle current food insecurities issues towards a more sustainable food system? So when we search for the materials, we go through 3 protocols. So we look for the materials from renowned online databases. And for this systematic literature review, the main databases that we used were Scopus, Science Direct, Emerald, Frontiers, and all the other, also MDPI database as well. And protocol 2, we make sure that precise keywords should be present in the title, in the abstract, or the keywords of the paper. And finally, we only include published English peer-reviewed journals. And after that, we evaluate and select all the relevant papers, and we incorporate the important information from the articles into a spreadsheet. And we all in all, we managed to gather 48 articles, and after analyzing and synthesizing, we came up with 3 themes for each research question. And finally, we report the findings. So for the first research question, the 3 themes that we came up with after analyzing and synthesizing the papers that we found, there are 3 themes that we found. The impact of COVID-19 on food security in Southeast Asia, which are the impact on food supply chain, the impact on food trade, and the impact on household consumption and behavioral patterns. So the impact on the food supply chain, we can see that there are transportation blockage, and basically the pandemic hindered the entire food supply chain process from start to end. And this was mainly because of the countermeasures to COVID-19, such as lockdowns, movement controls, and quarantine measures. So as a result, food production in the agriculture sector was halted, and it resulting in a delay in the supply chain. Okay, especially where there is labor-intensive farms, and because of the quarantine measures, lockdown measures, there were labor shortages. Also, we found under this theme, there was increase in food waste due to delays in the transportation and packaging of fresh food products, perishables. And finally, under this theme, there was also, we can see a rise in food prices and food shortages under this theme. So it can be seen the significant increase in food prices was seen in food commodities such as rice and wheat, and they are an important staple in Southeast Asia. The second theme, the impact on food trade. The main finding from this theme was that the temporary trade barriers such as export controls and bans, it triggered price volatility in food. For example, a good example in Southeast Asia was the Vietnam's temporary export ban on rice during the pandemic, which affected the rice supply in Malaysia at that time. So Vietnam was one of the largest net food exporters of rice to Malaysia, and it accounts for 30 to 40% of the overall rice supply needed to feed Malaysia's population. So due to this temporary barrier, it resulted in Malaysia stockpiling rice that could last for 2.5 months, but at a much higher price. And the third theme that we found under this research question is the impact on household consumption and behavioral patterns. We can see that consumers now demand for more non-perishable food commodities, okay, and so that they demand for food that has a longer shelf life so they can store it. And we can see that there is also a disruption of household income. You can see the figure, farmers lose their income by 39%. And this was in, I think, Thailand, due to the inability to proceed with production. And there is also a change in perception of food safety, whereby consumers are now more concerned about hygiene in food products, as many fear that the virus can be transmitted to the food products. And the second research question on sustainable strategies towards a sustainable food system in Southeast Asia. We looked for papers that recommends the best practices for sustainable strategies for a sustainable food system. And these are the three themes that we could find for this under this research question. The first one is by implementing a shorter food supply chain. This will promote sustainable farming, provides an alternative food chain, and develop a resilient agriculture community. And we can, papers also stated that buying locally sourced food could reduce carbon footprint, and this would be more sustainable and less pollution for the agri-food sector. And we also found that the ASEAN Economic Community Blueprint 2025, they have developed local, they have actually recommended for countries to develop their local food production to become more sustainable and resilient. And the second theme under this research question is the sustainable production and consumption. There were a lot of papers looking at a shift in dietary patterns. Then this would be more sustainable, and it can reduce greenhouse emissions, and minimize the pressure on agricultural land use. And there's a lot of papers talking about climate smart agriculture, which is a strategy to boost local agriculture production while at the same time mitigating climate change. And finally, the third theme under the sustainable strategy is the adapting technology to build food system resilience. There's a lot of talk about digitalization of agriculture, smart farming, to transform the food supply chain and to exploit digital tools such as e-commerce, mobile technology, artificial intelligence to promote or to improve global food system resilience. And finally, conclusion and way forward, the food system in Southeast Asia, we can see that it is highly vulnerable to the shocks caused by the pandemic. And the food supply chain was severely affected by the lockdown, movement controls, and panic buying. And furthermore, the labor shortage, trade barriers, and border closure also affected the food trade. So we can see that the COVID-19 is also a blessing because it has presented opportunities for the Southeast Asia region, ASEAN, to transform its food system into a more sustainable and resilient one. Thank you.
Thanks, Siti, and great that very interesting presentation and perfectly to time in the end. So thank you very much. I'd just now like to introduce our discussant, Wen Chu Yan, who is an associate professor in the School of Business Administration at Zhongnan University of Economics and Law in China. So just while he's getting in here, welcome Wen-Shu, and we're looking forward to your discussion of the paper. Thank you.
Thank you so much, Professor Alan, and many thanks to Dr. Musa's good presentation, and many thanks to Professor Wang Ling for his invitation to discuss this paper. And Musa did a really good presentation, and her talking is much better than what he wrote. I guess, I'm sorry. And it just summarized the paper. And the paper is an interesting topic. The paper tries to explore the impact of COVID-19 on food security and proposes sustainable strategy towards a more sustainable food system in Southeast Asia regions. And this paper adopts a systematic research review as a methodology, as documented by Center in 2019. And the paper has 4 findings. The main findings. The first one is that the food system in Southeast Asia region is highly vulnerable to the shock caused by the COVID-19. And the disruption of the supply chain was highly affected due to the lockdown, the movement controls, and the panic buying. The third one is the food trade interfered with the labor shortage, trade barriers, and border closure. And last one is the storage behavior of the individuals. That means a shift in household consumption, and the household prefer to consumption more non-perishable items than perishable items. This story is that the household would like to store some private items, I guess. And this paper contributes to the context of the impact of COVID-19 on food security in Southeast Asian regions, and provide some recommendations as well. The following, I just give some comments. The first one is, this paper talked about the food security issue related to Southeast Asia countries in a separate section. Because this paper focuses on this specific region, I suggest the author can talk about the food issue and the background and current food security issue in a separate section to highlight the importance of this topic. The second one is that I found that your author, I'm not sure if the author could improve the methodology, because when you list lots of the factors, if you improve your methodology, I'm not sure which methodology you could use. And if you could identify which of the factors are more important quantitatively. Firstly, it can make your findings more convincing. And secondly, it can help you to order the priority of the policy recommendations. Because you talk about the global value chains, the transportations, and the trade policies, lots of factors. If you can order the policy recommendations, it should be much better. The third one is, when I read your paper, it seems that the findings are also common in other regions as well. I'm not sure if you could try to explore new mechanisms that how COVID-19 affect food security in the specific region based on the specific characteristics of Southeast Asian countries. Because you have to analyze how COVID-19 affects food security based on the specific characteristics in this region, like how COVID-19 affects labor-intensive production in Southeast Asian countries, and how COVID-19 affects agricultural prices, then in turn affect poverty and malnutrition. And the third one is how trade policy changes in Southeast Asian countries, like the Thailand, Vietnam, how these two countries ban their exports, and then in turn affect the poverty, the malnutrition, and all inequality, like these types of food security issue. you can talk about what are the differences between Southeast Asian countries and other region countries as well. And the last major comment is that maybe the recommendations are a bit too general, and I'm not sure your paper combine the food security issue with the sustainable food system transformation is good, but I think you can provide more specific suggestions. And finally, I just give some minor comments. The first one is the last paragraph in the introduction, trying to discuss how global food security is attributed to COVID-19. Do not talk about other things. That means the global food security is because of the COVID-19. In table 1, only 9 countries are listed in the introduction. You said, but only 2, when you're in this table, in table 1, only 9 countries are listed. But when you write this paragraph in the introduction, you said that 2 members out of 10 in Asian have ranked like this is 9, this is 10. And third one is, why not include some articles are not related to food security, that's related to food security and COVID-19, but not related to Southeast Asian countries, which may help you to draw some policy implications for Southeast Asian countries. Like I list one paper, that paper is published in 2014, that is the food security policy options for China, lessons from other countries. That's published in the food policy, and maybe help you to how link your review articles with the other papers that are not directly related to Southeast Asia countries. And I guess the combined paragraph 2 at page 6 with the impact on household consumption and behavior pattern, because this paragraph talks about the demand changes of households. And this is my brief comment. Thank you very much, Professor Allen. Thank you so much.
Okay, thank you very much. Let's just get back to everything.
How to...
Oh, am I muted at the moment? Sorry.
Okay, no. Okay, good.
Okay, sorry, okay. Thanks. Sorry, I just I went to chat at the time as this was going on. Siti, would you like to respond initially to those comments before I open it up for other questions?
Thank you, Prof. Thank you, Prof, for your comments. About the methodology, I used the qualitative systematic literature review methodology. And for the keywords that we selected, we made sure that only papers that have the relevant keywords are reviewed and analyzed. So we made sure that certain keywords like Southeast Asia, and we also put in country's name when we search for the papers. So for that comment, even though the problems or the impact of COVID-19 seem general, but actually those papers are actually to do with countries in Southeast Asia in particular. But for research question 2, I agree with your comment that I should focus more on the strategies that are more relevant to countries in Southeast Asia. Yep. And I think on the quantitative part, I'm not so sure how to rank the themes according to priority, because it's a thematic or content analysis. So the way we analyze all the papers according to which the themes that come up now and then. So those are the 3 themes that we found that comes in the paper all the time. So those are the themes that we put in, but I'm not so sure how I can do it quantitatively for this methodology. Thank you.
Okay, thank you.
Okay, great, thanks. I have a question from Novi here. They say, as mentioned earlier in your research, there's a shift in dietary and behavioral patterns which can reduce greenhouse gas emissions and minimize the pressure on agricultural land use. Could you please specify what kind of changing behavior you're referring to here?
Yeah. So I'm referring to the paper at the moment. So the change in behavior is changing in dietary habits, particularly for the demand for animal-based products. So the change in behavior would be changing your dietary habits to eating less meat and particularly beef. Okay, so they move towards more a plant-based diet, right? And also, and yeah, so a plant-based diet, and also because beef accounts for almost 60% of the overall greenhouse emission, and that is twice the emission from plant-based food production. So this is what I found in the paper from our analysis.
Okay, thanks.
I hope that answers your question.
Hopefully Novi's happy. I can't see them on my screen, so hopefully they are. Any other questions for City while we've got the opportunity here?
Okay, I think we have iya, Pak Safi itu enak mesti.
Oh, is that a question or just an interruption? I think. Yes, Novi's happy with your answer, so thank you, City, for that. That's great. I'm just kind of interested, and I think it follows on a little bit from Wenshu's point. You know, when you were looking at those challenges in Southeast Asia, I would have said that's very similar to what we've discussed happened to New Zealand systems and other food systems. So I think that is kind of interesting that, I mean, the consequences may have been more severe, but the challenges do seem quite global in terms of the impact. I don't know what you think about that.
Yeah, I think so. But I think, like you said, the impact might be different because of the importance of, like you've seen just now, the importance of the agri-food sector in most of the countries. The labor force percentage is higher, and some of them, it is their livelihoods for the farmers. So might be in a global scale, the impact might be the same, but the impact might be somehow more different according to countries.
Cool. Yeah. Thanks very much. If there are no other questions, I would just like to thank City for the great presentation and for Wenshu for their very thoughtful discussion of it. We're just checking to see whether the last speaker is here. Respecting Pen Cheng Wang, who's Associate Professor of Applied Economics at the School of Economics at Guizhou University, China. Is he here?
Yeah, no, he's not here. Probably we need to close the conference for today.
Right. Unfortunately, the speaker doesn't seem to have joined us today. That's unfortunate, but I think fortunately also it was our last speaker. So those of you in Asia will get an earlier lunch, and those of us in New Zealand will be able to have our tea slightly earlier today. So maybe it's all worked out quite well. I'd just like to thank all the speakers and all the discussants for today and for this afternoon session. Some very interesting paper, very nicely presented by you all, and I really appreciated that. You kept to time, it was very clear and very well presented, but also thank you to the discussants. You really brought out some very key issues and things to discuss with the paper, so hopefully The authors can take that back when they're revising the paper and take those very thoughtful things into consideration. And thanks to those who also contributed questions, it also obviously helps make the session more interactive and enjoyable. So again, thanks to those who organized the conference. I've had a very enjoyable session this evening. And I think I will pass over to conference organizer to close this session. Is that right?
Yes, we pass it to Dr. Harry Toiba.
All right. I'll pass over to you. Thank you.
Yeah.
Okay. Thank you, Prof. Renrich, the keynote speaker and presenters and discussion for excellent performance. As time goes by, we are approaching the end of today's sessions, and I would like to invite Associate Professor Harry Toiba as the Chairman of Agriculture Socio-Economic Department, Faculty of Agriculture, Brawijaya University, to officially close our program today. To Dr. Toiba, time and screen are yours.
Thank you, moderator. Good afternoon, everyone. It has been a pleasure being with all of you studying today. On behalf of Department of Agriculture, Socio-Economic, Faculty of Agriculture, Brawijaya University, Indonesia, and organizing committee, I am delighted to deliver this closing remark for the first day virtual international conference on the success of the promoting sustainable food production, challenges, practices, impact, and solution, which were held virtually. I would like to many thank our distinguished keynote speaker, Professor Fu Jinyi from Nanjing Agricultural University, China, who shared his valuable experiences at the morning session. Our moderator, Associate Professor Kiki Febrianto from Brawijaya University, our session chair today, Associate Professor Zhao Huali and Professor Alan Rinswick from Lincoln University, New Zealand, all the presenters, all the discussion, and all the parties who have contributed their best effort and assistance in organizing the event and ensuring the success of the first day virtual international conference. So this conference will look expand our understanding of challenges, practices, impact, and solution associated with the sustainable food production, especially for smallholder farmer in developing countries. I do hope that the virtual international conference is able to impact all of us to greatly foster and empower the smallholder farmer and society through promoting sustainable food production. Tomorrow, we will still have the last agenda, namely the afternoon session, start 20:30 Bangkok Standard Time, with the keynote speaker, Dr. Dil Rahut, a Vice Chair of Research at the Asian Development Bank Institute, and the session chair are Dr. Wahida from the Indonesian Center for Agriculture, Socio-Economic and Policy Studies, Ministry of Agriculture, the Republic of Indonesia, and Professor Bustanul Arifin from Lampung University, Indonesia, and 7 presenter and discussion. Finally, thank you for the great contribution. Looking forward to seeing you in the next agenda. Thank you for your kind attention. Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.
Bye.
Join us at Lincoln and get ready to meet the demand for qualified professionals. Lincoln offers world-class facilities for research and learning, lecturers who know you by name, dedicated wellbeing and support staff, and practical learning experiences to connect you with the industry before you even complete your degree.
I chose to study at Lincoln University because it had the additional major of Parks and Outdoor Recreation and other environmental degrees that I'm interested in.
What I enjoy about Lincoln is a small campus size and approachable lecturers.
I chose Lincoln for its sports scholarships, and it also offers food science, which I'm really interested in.
I've enjoyed studying at Lincoln because, one, it's highly academic and a great course, and second, the social aspect of the Lincoln University is incredible.
Lincoln is special because the students get a hands-on experience at the same time as learning the theory for their discipline. I feel this really sets them up well for a career in whatever industry they choose.
Students should come to Lincoln if they really want their degree to mean something. If they want to do a science degree and they want to align that degree with New Zealand's biggest, most important industry.
One of the other things you learn well at Lincoln is how to engage and understand multiple perspectives, and we work often in small classes so that you're able to debate and learn from one another.
At Lincoln, you're not just another number. We get to know your name and to know who you are.
If you think about what future careers could be and what shortages we may have in the future, I think one of them will be proposing solutions to add value to the current food production. There will be more and more opportunities for science graduates, even outside the traditional scientific jobs.
Horticulture is a vital part of New Zealand's future. There's a number of areas that students could go into: vegetable and fruit production, nursery production, and so forth. And the future is bright for any students qualifying from here.
The agricultural industry needs people who can think, people who can understand the first principles of how plants grow, how animals grow, how we put production systems together, how we integrate those into the environment.
At Lincoln, environment and sustainability is at the core of what we do. Our staff are very engaged in these issues and have a really broad range of experience and knowledge.
So when we talk to food companies and food industries, they often ask us for graduates who have expertise in different areas, especially for food production, because it's very diverse.
Our students go into a range of careers in both the public and private sectors, and they make a big difference in their communities and to the environment.
What makes Lincoln special for students studying here is the number of field trips they go on and the practical hands-on training in the labs.
Once I finish study at Lincoln University, I'd love to start my own orchard.
After I finish my study at Lincoln, I want to use my food science degree, maybe go into nutrition, continue to play basketball, and maybe own a gym.
After Lincoln, I'm planning on going to the arable agronomy field for studying crop science.
When I finish my degree, I'd like to work in the environmental sector on cultural and sustainable issues.
Join us at Lincoln and get ready to meet the demand for qualified professionals. Grow your career at Lincoln University. Apply now.
nanti ngawal Pak Kusno karena listriknya ini mati, jadi setelah ini diperbaiki sehingga besok karena acaranya sampai malam, ya sampai hampir maghrib, sehingga lampunya harus nyala. Kalau nggak nyala kan kayak rumah hantu gitu kan. Jadi nanti mohon dikawal Pak Rahman ya. Berharap besok siang itu sudah ready untuk nyala. Lampu ini loh Pak Rahman. Loh maksudnya saya minta ngawal ke Pak Kusno. Ya, oke. Terus yang kedua besok berharap datang lebih awal dan Mbak Novi jangan lupa menghubungi Pak Daman. Jangan